All right. So we are recording these sessions. After the day is over, I will typically post them to my YouTube channel, and we'll go over that a little bit later. For those that don't know me, my name is Kerry Bruce. I am a CIS instructor at Central New Mexico Community College in Albuquerque, New Mexico. I teach CompTIA courses, A+, Net+, Security+, Cloud+. I teach our server courses. So we use Server 2019. So I teach a couple of those, PowerShell. We're doing an AWS architect course that I'm getting trained on now. And then I teach our IoT, Internet of Things course, and I teach our competitive robotics courses. We have two. We have an introduction and an advanced. I'm also the facilitator for a student group called C&M Hackerspace, which is a technology-related student group that is designed to basically, we have open lab once a week, usually 3 or 4 hours, where I provide access to the lab. In the lab, our lab has robots, Raspberry Pis, Arduinos, 3D printers, laser cutters, I guess, a laser cutter, a glow forge. So, old PCs that were donated, networking parts. We've got an armed robot that like it has arms. It doesn't have weapons, it has arms. That people can learn a program to use to learn grappling, something like that. So we basically open up the lab, and then based on whatever is of interest to the students, we provide them with the materials, possibly some instructions, some assistance, get groups of students together to do things like that. We do have a competitive robotics team. We competed in Pi Wars, which is a Raspberry Pi based robotics competition. It's held in Cambridge, England, every year. The last 2 years have been virtual. They have just reached out to everybody to see if everybody's willing to come next year in person. So hopefully we go back to in person. That becomes a global experience for my students. Most of my students that have gone have never been out of the country. And some of them, in fact, some of them never been out of the state. So we teach them how to build a robot, and they program the robot, and they have to compete in this competition, but we also at the same time take them to England, so they get that experience as well. So that's what I do on a day-to-day basis. I do teach all year long. I'm a 3-term instructor, so I teach spring, summer, and fall. In the summers, I only teach 2 classes because I teach extra classes in the fall and spring so that I can do these kind of workshops and I can travel in the summer. And that's what I am. That's what I do. I get paid to talk about computers and play, so I'm in good shape. So I'm not complaining. This workshop, the idea of this workshop comes from, I really enjoy the Raspberry Pi, right? So the Raspberry Pi is a credit card sized computer. I'm gonna assume, and I probably shouldn't assume. I assume that most people, let me share my screen, are familiar with the Raspberry Pi or what it is. And if not, you're here because you're curious about what a Raspberry Pi is. I'm trying to get my video and chat up on the screen so I can see it. So Raspberry Pi, this is a Raspberry Pi, right? So this is a credit card sized computer. This is the Pi 3, I believe, and this is a Pi 4. These 2 items here, right? So slight variations between the 2. I mean, better processor, better. The 4 has better wireless, better Bluetooth. It has 2 HDMI's, micro HDMI's versus a regular HDMI. These 2 HDMI's can push out 4K video. In a $35 computer, right? So the base version, which is 2 gigs of RAM, can push out 4K, as does the $75 version, which is 8 gigs of RAM. But the idea of these things, the reason why I am so enamored with the Raspberry Pi is that it reminded me of when I started learning computers. So back in the early 80s, right? So I picked up my first computer, which was a Commodore VIC-20. That's my first computer. And much like the Raspberry Pi, you have to learn how it works in order to make it do what you want it to do in a lot of cases. And to me, that as an instructor of computing, right, that's a super exciting prospect that I can, put into my students' hands for, $100 when you add all the pieces and parts on a normal day, right? So right now is not a normal time, right? Because the chip shortage worldwide, and some decisions that Raspberry made to make sure industry had enough gear. The DIY side of this, so this getting out to the normal end user like me and you, they're expensive right now, right? So kits that used to cost $130 are now like $260, $280 because of the chip shortage. So be aware of that. Like right now, costs is a constraint. However, even at $260, it's less expensive than a student buying a laptop, right? And I can use this in a bunch of different classes and teach a bunch of different topics and different things. So my hope or my thinking is I started this about, 2 years ago. I did a presentation for WASTC. Did a presentation. I'm drawing a blank on the folks out in Texas, but I did the same presentation for them as well. But the idea that I can use this $35 device to teach students like all kinds of CIS topics. That was the start of that. And then for this particular workshop, we're going to focus on some of the cybersecurity aspects of what can we use the Raspberry Pi to teach, how can we use the Raspberry Pi to teach cybersecurity to our students. So that's kind of where this workshop comes from, okay? The idea of this, it was done in a presentation about 1.5 years ago now. But I want to kind of concentrate on here, like why the Raspberry Pi, right? Why do I like this as a device, right? For me, it's a tool, right? It's not the end all be all. There's other things that we use. We use online labs. We use computers in the classroom. I use virtual machines on a Nutanix system for my server classes. We use, online curriculum. We use textbooks. There's all kinds of things. This is a tool that I truly believe if we were to give or get our students to purchase one or give them, I don't know, whatever process you want to come up with, but on day one of a CIS program, and we integrate a lab or two into each of our courses, they would be able to use this device over a 2-year, 3-year period as they're learning computing, and they can reuse it over and over again, right, as a tool in the classroom. So the first reason why I like it, low cost. I've already kind of talked about that, right? So $100 or so on a normal day. Right now it's like $200 is the norm today. But if you add on extra parts, a case, and some fancy other components and pieces or adapters and things, you're talking between $100 and $300 on any given day, or your total investment in this tool, right? And I will tell you, I know at one point in time, our server textbook was $225 for a single class. And it was one of those ones where you get it, you use it, and you never touch it again. So the trade-off here is like, let's get this equipment at that same textbook cost, but then let's use it multiple times throughout our learning process here at going through a CIS program. So the first thing is cost. Second thing is flexibility, right? It is a desktop computer. It's a single board computer. It has a processor on it that's similar to the processor that you'll find in any typical smartphone today. It's an ARM processor, quad core, 64-bit. The newest version, the Raspberry Pi 4, has 2 gigs, 4 gigs, and 8 gigs of RAM. It has Wi-Fi 802.11 AC. It's got a gigabit Ethernet port on it. So it's got all kinds of cool things. Plus, For those who like physical computing and sensors and IoT type stuff, it has those GPIO pins, which a computer, your typical laptop, your typical PC is not ever going to have those components built into them, right? So not only can I use it as a regular computer, but I can have them turn it into a web streaming device. I can turn it into, 2 weeks ago, we turned them into web servers. In this class, we're going to maybe turn one into a firewall or a VPN concentrator, right? So I can turn these devices, they're inexpensive. Like I can turn this device into that and leave it there. And I would be okay buying another $35 version. I wouldn't want to buy a $500 laptop, turn it into a firewall, and then go buy another $500 laptop. So I think that's one of the things that I really like about it as well, is that flexibility that you have with the fact that it is a computer, plus it has the GPIOs, and there's this, and we'll get to number 4 in a minute, but there's this monstrous community around this device, where then if you just type in anything into Google, Google Raspberry Pi DNS server, you'll find 5 or 6 tutorials on how to do that, right? And you can find the best one that you like, the one that you're the most comfortable with, the one that you feel is going to work every time your students do it, and then you can implement that as a lab in your classroom, right? The next one is power and size, right? So this is kind of keying off some things I already talked about. It's tiny, right? So you can put it in a case, you can put it in a little box or container or Ziploc bag, inside of a case, and throw that in your backpack, right? So it doesn't take up a lot of space. It's really easy to transport. And you get a fully functional computer in that space, right? We have labs where I have my students can plug in the Raspberry into monitors. So the monitors, keyboards, and mice that are in the labs, they don't need to have extras of those. In my class, we teach them how to remotely connect to their Raspberry Pis, so they can go home and plug it into the network, and they don't have to actually have extra keyboards, mice, or mouse to do that. They just use whatever their computer is at their house. The 4th reason why I like the Raspberry Pi in the classroom is, I mentioned a second ago, is that community around the Raspberry Pi. It's very similar in size and veracity as like the Arduino community. If you search Arduino and some sensor, you'll get 50 different things that you can do with it. Do the same thing with the Raspberry, you'll get 50 different things that you can do with it. And they're usually, most people will do these projects and then share their code, share their ideas, share their 3D models. Other things that they do, they'll share all that kind of stuff out there. So there's a lot of open source related around this. So it's easy to take those and integrate those into the classroom and find those things. And you'll see, I hope you'll see this week that community come through, because I'll share with you a ton of things that I've just found based on searching for certain things. So the ESD damage, I would say, if you're, I'm answering a question. Sorry, it was a direct question, but it's okay. I'm going to answer it. So, how susceptible are these to ESD? Well, if you leave them plugged in and you start to, you're wiring them up while everything is plugged in, I've had students damage Raspberry Pis that way because they plugged in the 5 volts, right? Or they dropped a wire and it crossed 5 in ground or crossed 3 in ground. For the most part, though, it's a minor issue. And then if it is of concern, like I'm trying to find, I have, you can put a case around it to protect from that. So if we take a look, like I just have these kind of cases here, so these kind of break apart. So then if I need access to the inside of it, I can take the top off and just access what I need. I'm not holding on to the Raspberry when it's in the case. So that's one good way to do it. The other, I'm trying to find it. I'm gonna take my headphones off and show you one other option. So in my classroom, we've gone to these, right? This is a Raspberry Pi 4, and I'm gonna have 0 ESD issues with this, because you can't touch it, right? But you can get access to the pins. You get access to all the ports. It even has a little display on it. This is a Pi top. These are an expensive version, right? It costs a couple $100 on a normal, again, on a normal day, it costs a couple $100. However, like in the classroom, that will eliminate that kind of problem. And then you can also, purchase the keyboard. This is a touchscreen monitor. There's a keyboard, touchscreen monitor, and then the Raspberry pops on the back. So it looks like, it's like a Surface laptop type of a deal. So that's a solution if ESD is an issue for you. I have had, we have had failures. And I think it took us we had 30, the first time we ran this at all in classrooms, we had 30 in the lab, and we made kits, and everybody would have a kit assigned to them each semester. And it took us maybe six or seven semesters before we started losing components enough for there to be like, okay, wait a second, we need to come up with a different solution here. So, and in that time frame, I think there was 2 new versions of the Raspberry Pi. We've switched over to our students buying their own. And I will tell you, maybe once a year, I teach the class 4 times a year. And maybe once a year, I have somebody mess up their Raspberry, like to the point where it's not functioning. And, a lot of times it's, they're just doing something weird, or they leave it powered on when they're doing things. If you take it and take the power out while you're doing stuff, 90% of the time, more like 95% of the time, you're not going to have any problems. The link, you're talking about the Pi tops? Yeah, this is my favorite. This is my favorite system. It's a fun. Trying to get to everyone. There we go. So Pi top, and then you have this really cool robotics kit. So, so there's the Pi top, and then you have the keyboard monitor combination that you can purchase separately, and then they have a robotics kit. They also have I don't make any money from Pi top. I really like Pi top, so I want you guys to know that. I'll tell you if it's sponsored. It's not sponsored. This is just me being passionate about this piece, this equipment. I really like this equipment. So much so that I just bought 60 from my lab. So that also comes, you can buy this foundation kit. And this is another really cool way to do, instead of doing sensors. So this again eliminates that whole ESD issue. Like, so this isn't, oops, let me take the top off here. Comes like this, right? And then this is an LED, right? And it uses the little like Groove Pi type jumper wires. So you take this plate and you snap it to the bottom of the Raspberry. Oops, I missed. Snap it to the bottom of the Raspberry, maybe, if I get it right. Line it up. There we go. Snap it to the bottom of the Raspberry. Then I can take, you get the wires, right? And you just plug in, wherever you want to program the port to it. And then that you can then light that up, right? So I think from a classroom perspective, like this is the safest way to keep things from getting screwed up. Right? So if you're going to do classroom sets, I think this is the investment type that you should go. I think as students, right, they can get away with this and a case and be careful because they own the equipment. I don't know if you guys have noticed it, but when people don't own their own equipment, whether they're students or employees, they don't take as good of care of it as if they owned it, right? So if they're paying for it, they take a little bit more caution when things get messed with. The other cool thing about this kit is they have these magnetized to the bottom, and then your breadboard becomes a Lego board, right? So you just plug these onto the Lego board. So I think that's, again, another totally awesome way to do that. So if this is completely just my recommendation. If you're doing, and the reason why I recommend, I've done it, like, do as I say kind of thing, and do as I do kind of thing. If you're building a lab for a classroom, right, this is the way to go, right? There is another option. Hold on one second. And this is all stemming from the question that was answered, so I apologize. If you guys haven't ever taken classes with me, this is what happens all the time. I get a question, we get interested, we move off into a different direction. We'll get back to what I was talking about in a minute, but I promise you. But so that's one way to do it. This is the way I do it, right, in my classroom. And then another reason why I like that is they also have this bad boy, right, which is a robotics kit, right? And those of you that are .NET programmers, they have software that runs on this that allows you to take this robot and connect it to a Microsoft Teams channel, and then students can connect to that same channel and send .NET code to this robot from anywhere in the world, as long as they're connected to it via that channel. Like, it's totally awesome. They also, when you buy those things, they come with some online learning. So how to, the basics of that. They get all the way into doing facial recognition, and if you're doing if you have the robotics kits, on how to follow lines and how to, recognize colors and make choices and decisions based on that. I don't know if there's a discount for education. I can track down my contacts and hand those over so you can check it out. The other option, as far as trying to protect from from ESD, this is a Pi 400. So this has a Raspberry Pi 400 built into it. It's in a completely different format. So if you were to take the cover apart, you will notice it's not a Raspberry Pi stuck in the keyboard, but it does have all of the parts and pieces of a Raspberry Pi 4. The one thing about this is that you still have the, I didn't lose it, I just misplaced it. There's a board that I can plug into the back here that will give me access to the pins, right? Because here's the pins. And so you could actually technically, I guess, wire directly into that, but this is the Raspberry Pi 4 in a keyboard form. This normally sells for like, I don't know, $100. Is that what it is? It usually comes with the video cable and a mouse. And then all you do is just plug it into a monitor. And, so in my lab, we just have, I have a lab where we have a computer with a monitor, and we have an extra monitor, or actually each of those monitors has a pigtail off of it to plug in an HDMI. But that's another option. It's the Pi 400. And we're going to go to that website in a little while when we hit the Raspberry Pi website. Well, here's the device else. So this is like a $4 part. So this is like $100, and then this is maybe if I can get it out of the bag. That's sticky on it. This is a $5 part that you can get from SparkFun, and it literally plugs in, and you have the pins here. You also have these quick connects, which they're not the same quick connectors that come with the Pi top, but SparkFun has a ton of sensors that connect to these quick connects. So you can avoid the whole plugging into wires here and just quick connect, and then quick connects can daisy chain. In fact, I will share with you when I get around to finding it. One of our other instructors that's taken a bunch of our courses, she put together a really nice presentation about the quick connects and how to use them with a Raspberry Pi. So we'll make sure that we get you access to that as well. But those are two options to answer the question on ESD damage. I would use those two products to avoid the ESD as much as possible. Otherwise, right, Raspberry Pi is in a case, and then anytime you're messing with the Raspberry Pi, turn off power. Right, those will be the two recommendations. I'm going to write down the question about Pi top discounts for education. So I think if we go to Pi top, like if we go to the That's all the education stuff, but the products are here. Some robotic kits. I just want to kind of show you what I'm talking about. I think they have like a, yeah, so they have a robotics superset. So this is a 12 pack, which has all of these pieces, and that's the price. $400 a piece or so. That includes the robot, that includes the Pi, I believe it includes the Pi, it includes the, there's a couple other things it includes as well. So pretty nice stuff, but it is on the price, you know, when you're considering all of these things, that's on there, it's on the pricey side. But it's rock solid gear. I've had really good luck. I've used Pi top components from the day they started, right? And in fact, I've taken my team, my robotics teams, to visit their headquarters in London twice. And they were really gracious to show us around. And in fact, one year they actually showed us how their Google Cloud worked, and they actually did updates like right in the middle of the day. They updated a website for us to show us how Kubernetes worked and how containers worked. I mean, we're sitting in that conference room, and he's just, you know, the students were just soaking up it was really cool. It was really cool. I think you could probably eventually get it out of the case if you really wanted to. There's actually a kit that allows you to put a Pi 4 in the case. Like, so if you already have a Pi 4, you can actually, there's a kit that allows you to build, like, you know, put the case on a Pi 4 for like $100, something like that. So, yeah, it's a typical Carey class. Like within an hour, or within a half an hour, we're already sidetracked. I love it. This is awesome. All right. Item 5, why I like to have the Raspberry Pis in the classroom. Tactile learning opportunities. I don't know if anybody agrees with me or not. I think most instructors agree to some extent that having the students physically do something is a whole lot more meaningful, and like the retention of that is much better than if they have them go online to do a lab online, or take a quiz, or whatever the case may be. But so I'm really big on tactile. I really want my students to actually do things, right? I want them to work on things, and I want there to be, you know, in the case of the Raspberry Pi, like if you do something wrong, like it's wrong, we got to fix it kind of thing. So they get that real world experience, right? Because if a lab goes wrong, like if, you know, I'll pick on test out at this point, but if a test out lab goes wrong, what do? They just reset the lab and start over, right? If something goes wrong in the Raspberry Pi, like we can't just reset. We got to back out of the problem or fix the problem, kind of a thing. I've set up the same kind of scenario in my server class. My server class, they get 5 VMs. They've got to build out 4 different servers and a desktop machine. And then they have to install, you know, roles and features and get things to communicate and get things to connect. And there isn't any backing out unless they've followed the instructions and created snapshots, right? So then they learn system admin, right? Because you can't just stop the lab if you've gone in and done, you know, 17 steps. You can't just stop the lab and start over because it's a real server. So the same kind of thing here, like it's a tactile experience. You got to work through the issues. And I'll tell you, for some of my students, especially in IoT, those kind of things become frustrating. But I want them to understand, like, this is how it works in the real world. You don't get a reset. Like, you got to figure out what happened, and you got to fix that problem. And I walk them through how to do that. I mean, that's part of the classes, to teach them to think outside the box and to work around those issues. So this tactile learning opportunity, I think, is really important. Okay. And the very last piece, and I think Tony said at the very beginning, right? They're fun to play with, right? And the reason why, and I think it's important, right? I think it's important that you have fun doing this. Like, so I've been in the field. I've been paid to work on or talk about computers since 1994. I played with computers back all the way to 1981. And yes, there's times when it's frustrating, and yes, there's times when you just want to give up, but most of the time, for me, playing with computers is fun. So I want to bring that funness into the classroom, and I really think this these types of objects do that, like this Raspberry Pi and these labs that we're going to look at this week do that for the student. So low cost, flexibility, power, size, community, tactile, fun, all of those things are reasons why, right, I like to integrate these things in. And that's the impetus for why I do these workshops, right? To share that with you, right? A lot of this is just, it's a learning opportunity for all of us, because I know without a doubt that some of you have other experiences that you know, once we add them to the whole, is going to make everything a whole lot cooler for everybody, right? a lot of opportunities for everybody to do things. From that same, right, that same lecture class that we did, I mean, just kind of to show you some ideas. Every single one of these is a hyperlink to a lab or resource that's available that will, right? So just to kind of show you all the things that we can do, right? So this, we have a really small piece here that I've actually documented. If we look at my, where did my Raspberry resources go? Right here, Raspberry resources, cybersecurity. We have a much bigger list of things to go over this week. So we're going to fill up the time. I promise you, we're going to fill up the time with really fun things that you will, you know, labs that you'll be able to use right away in class, labs that you may want to plan into future classes. I'm going to give you resources more than you can handle this week. That's typically my modus. We're going to have a week packed with information, and you'll have like a month worth of resources to follow through on at your leisure, right? None of the things that we're going to do here are required. I want you to, you know, to join in and have fun as much as you can. I want you to, you know, get some value out of the time that we have together. So this week is going to concentrate on cybersecurity, right? So we're going to concentrate on Raspberry Pi items, Raspberry Pi things that we can do to teach cybersecurity. That's the plan. All right. For those that like agendas, and, you know, in strict, if you like to have everything lined out ahead of time, this may be frustrating to you. This week may be frustrating to you, because that's about as lined up as we're going to get. Right. I have an idea of what I want to do. If I change things around, it's because the class dictates that. Right. I leave these workshops really flexible. I don't want to put down, you know, an official agenda, because if I miss a step or something, I don't want people, you know, to be upset about that. You know, we missed pieces or we're behind by 3 days or whatever. Like I said, we have 27 hours and we have lots of things that we can do, and we will do as many things as we possibly can in that time frame, and I will share as many resources as I possibly can in that time frame that fit with your interest and the, you know, in the idea and the concept of the topic of the class. Okay, so we do have a list for the week, and I have a list I make up every morning for each day. Okay, the lab wise, we have a set of labs that I want to look at. You know, so you can see right there, if that's all we did, that's probably 27 hours worth. I have a set of web labs that I really like, right? If I do only this, then that's 27 hours worth, right? So there's going to be some things that give way to other things. And then we also have software that we need to get to today. So things that we need to do. So I want to make sure that you realize, even though the web page that I gave you is completely blank, the class is not set up that way. Like it's, we have a plan, and we will flow through that plan as best as we can. Okay. So I hope that's, I don't know, maybe that eases some anxiety about the class. Like it's simply, we're going to play with a bunch of things. We're going to try a bunch of things. I'm going to share a bunch of things. When we get done, you should have a massive pile of resources that you can utilize right away. Like you could run one of these labs. You know, you could run a lab in your class that we do on Tuesday. You could run it in your class on Thursday. if you really wanted to and you had the equipment available. Okay, so that's the plan, and that's what I do. For those that have had me, you already understand that about me. For those that have never had a class with me, now you kind of have an idea, and by the end of the week, you'll see exactly what I'm talking about. Next thing, I did share with you a Google Drive, 2022 WASTC, right? Level up your cybersecurity skills. You should have gotten an email to whatever email you signed up for. I signed up for this class for. If you have a Gmail account like that you want to use differently, then just email me. Like there's a way for you to request access to that from that email. Like you can request access and just tell me which email and I'll go ahead and add you. I'll probably look at that at lunchtime, look at that at the end of the day. In this drive, we will share documentation related specifically what we cover in the class. The biggest one is going to be this workshop resources webpage. Last class that we did, I think we had 7 pages of web resources by the time we got done with the class. Okay, which is why I'm saying you're going to have easily a month's worth of resources that you can look into later on. Okay, the other document here is simply this was the document that was in the, maybe the document when you read it, you're like, oh, I want to take this, like that document, like this is just explaining the class. The part I want to make sure that we, right, to participate in the labs, right, 2 Raspberry Pis usually, because we're going to kind of do some things back and forth with some Raspberry Pis. But each one needs a power supply, a Raspberry Pi power supply, a micro SD card. You need a single SD card reader and whatever video cables you want to use. We are going to show you in today's setup how to run your computer headless, right? So you won't need to share. You won't need to connect to video if you don't want to connect to video. We're going to walk you through how to do that. A USB Ethernet adapter, in order to, if you want to create a router, right, or a firewall, we need to have 2 Ethernet adapters typically, and a Raspberry only comes with 1, so we use USB to do that. You need to have some kind of access to a Wi-Fi or Ethernet network, and then I'd like you to have 2 extra SD cards, right? So these are things that you can pick up. I'm looking for. Hopefully you saw those and you had those already, and then I didn't put a list up there. I apologize. I do have some links to kits and things like that if you want to go out and do those. The other piece is one extra piece that we did not include. So there's one lab that unless you have it as part of a SparkFun kit, there's one lab that it'll be a demo lab, and it is a USB. It's a cable that goes to 3 pinouts. Like we actually, one of the labs we're going to do is actually connecting a terminal connection, a serial tech connection to the GPIO pins, and opening up a terminal on the Raspberry Pi. So I have 15 of those cables here. So if you want one, and you just want to pay the shipping, I will give you the cable. The cable is normally $15. Right. So if you want one and you want to just pay the shipping from my house to your house, send me an email and send it to Carrie@myitinstructor.com. So I put the email. Oops, I just sent that on direct chat. Hold on a second. Carrie@myitinstructor.com. So that email, if you want USB to serial cable, will cost of shipping. All right. And I'll get that out to you. So then, and if we can get it done, I don't know, I think I would say priority mail is usually like $6, $7 at that size. Like we can put it in a really tiny envelope and get it out of here. First class would be less than $5 or so for most places. I think most of you, there's 3 of you on the East Coast. couple of you are in the DC area too, right? So those ones might be more expensive because of the distance. But if you want that cable, right, it's basically a serial cable that allows us to communicate to the serial pins, the GPIO pins on the Raspberry Pi, to actually open up a terminal session with the Raspberry Pi. It's a physical device level hack that we're going to do. And I apologize because I completely spaced it needing to be on the list. So if you want to order one, there are a couple options. Let's go to SparkFun real quick. I think it's a SparkFun thing. There's two options that you have with SparkFun. USB serial cable, I believe. Yes, this one here. So I'll drop this in the chat. So this is the cable, connects USB to the 3 serial ports. I believe this is the correct one, FT232, yeah. The other one was a 5 volt. We don't need the 5 volt one, I don't think. Right, so there's a 5 volt version here, I think. I don't know if there's a difference. I just think this one can handle, it says it's the same thing. Oh, it has 4 connectors here. We don't need the 4 connectors. So you only need this little one. We only need the 3 connectors. Okay, so the 3 connectors will do it. The other option, and if you bought it's this guy, right? This is the other option. Okay, so this is the other option here. USB-C, that has a C connector. It's a new one. Let me try to find this one. This is the breakout that we've used in the past, I believe. So this breakout here, yeah. The issue with this breakout is you typically need, there's pins underneath here. So let me copy this one over. This is the other option. If you bought a SparkFun kit, like if you bought one of the SparkFun kits that Cisco recommended, you may have this already. And you also will have the little, like this, the T, I call it a T connector, right? But it's one of those, let me find it in the kit and I'll show you what I'm talking about. The cable for me is a simpler way to do this, but if you have this other part, you can do it as well. Here we go. If you have this part from SparkFun, because it has the pins on the side over here. I don't think there's a better picture of that, but right, there's those pins plug, this thing plugs into the end, and then you wire it from here into your you actually plug USB to that plugs into there, and it goes right into your Raspberry, into the correct pins on your Raspberry Pi. Okay, so that's one of those. This is the other option. If you bought this kit, you know, as part of, this is the recommended kit from Cisco. If you bought this kit, you may already have these 2 pieces. You use this ribbon cable and these 2 pieces, and we can make that connection as well. And it looks like somebody else shared. Yeah, this cable should work as well. We just have to make sure that we have the right, it'll be some driver issues possibly, which is normal for these cables. And then Adafruit has a cable like this too. There's one from Adafruit as well. This one from Adafruit is a well-known one. So any of those would work. And if you want to buy one straight out, that's great. I have these SparkFun ones. And I can ship them to you today. Hopefully get them out today at lunchtime, or worst case, they go out in the morning. I can ship them to you for the cost of shipping. Because I have extras. Serial to USB. Right. So, and and the reason I would bring that up, I apologize for not having it on the list before, but that lab is neat. I don't know, it's like a physical hack, like you're actually physically hacking into the hardware through the serial connectors, like these GPIO ports. You're breaking into the machine, which I think is totally fun. So that device, you can get that one there. Does that help? Everybody's got the links there. There's a link to the one on Amazon. The Adafruit one, we should add the Adafruit one. Let's add that link out there too. Either one of those cables will be fine. It should all work. Normally, I don't have it up here. I'm not logged in. Normally, I would give you my associate link, but I don't have time today. It just helps me buy more Raspberry Pi parts. Essentially, anytime Amazon sends me a check, I go buy Raspberry stuff. So, awesome. All right, are we okay with parts and pieces? Like, so if you only have one Raspberry Pi, we'll be able to do most of the stuff to this week. We are going to do some VirtualBox stuff on your PC or laptop, and we're going to connect to the Raspberry Pi. So that's part of the deal there. But I just wanted to make sure that you knew that was there. The only other thing I've shared so far is in my research to get ready for this, I found some articles, and most of these articles are like academic articles, but they all relate to using the Raspberry Pi in the cybersecurity setting, right? So some pretty cool stuff, I think. For those of you that are in high school, right? So tempting high school students into cybersecurity with a slice of Raspberry Pi, right? Let's be creative. That's awesome. So there's, and they've got, an article with all the references, right? So for those of you who like, I don't know, I end up going down rabbit holes all the time, right? So there's some IDS stuff with the fog, IDS with IoT. There's some things on IoT privacy. And these are all articles that are, utilizing the Raspberry Pi to teach a solution, right? And these are all cybersecurity solutions. There is one, this book right here. I downloaded a chapter out of the, it's like a Raspberry Pi pranks book. But this is actually Wi-Fi pranks is actually like using, cybersecurity, using a Raspberry Pi to monitor your network. Now, if you're going to monitor wireless, you have to get a dongle that will allow injection. So that's the one caveat to doing wireless packet sniffing. You have to have a separate wireless dongle that specifically allows for that. And we can research that stuff a little bit later this week. So in this documentation, I've already started documentation. As we go throughout the week, as we find more articles and more resources, we'll put those, we'll fill out this document. And then you have access to this as editors. So all of you, if you have documents that you think would be interesting or web links, this is a shared document, right? So you are welcome to jump into this document and add things as we go. That's the whole point of this, is that I want this to be a sharing, right? This is a sharing deal where, I'll facilitate that. And if you have something that you want to contribute, please contribute so that everybody has access to it. All right. So that's the first folder that I gave you access to. The second folder that I gave you access to should be the IoT security class resources. So these are the resources that are instructor resources that come along with the Cisco IoT security class that you were all added to, this class here, right? If you weren't aware, there's two things here. You, as an instructor, no longer need to be certified to teach that class. So you can teach that class as long as you are a Cisco instructor, okay? You no longer have to be certified. The other thing is this ends of life, the end of life is at the end of July next year. So to teach the class in its current form, you have the fall, the spring, and the summer. Now, a lot of the labs that we're going to do this week, I think are labs that can easily be pulled out of the material and used standalone, right? So, which is why I'm showing you this material, right? This is the one class of the 3 IoT classes that I really wish they wouldn't end. The other ones are okay to end. The IoT connecting things, I've modified my course so much that all I have to do is find reading material for them to compensate for. Everything else I've been able to migrate out into its own form. The security class I have not done that with, because I really like what's in the security class. I didn't see a need for me to modify that. Now I've got to figure out, we're going to modify it and pull it out, make sure that it works. For those of you who know Marcelo has been working on Jupyter notebooks running on a regular Raspberry Pi OS and starting to migrate some of these Jupyter notebook labs out into a non-Cisco PLAP modified operating system. So stay tuned for those things. So I think by the time they get rid of this class, we'll have those things migrated out. So you'll have a lot of these labs that we're going to do, you should be able to do, going forward. You won't need to have the Cisco material for that, okay? But there's, so the 2 things there, you don't have to be certified any longer to teach the class. So you can teach the class, right? You should be able to create course, and IoT security should be one of the options you have to teach. And secondly, they end of life it for the end of July 2023. Okay. So we've covered the G Drive or the Google Drive resources, right? So there's lots of good resources here. There's some ebooks in here. I've actually given you I think all of the copies of all the NetCAD material. And as we talk about the course here in a little while, we'll go over some of that material that's available to you. All right. Cool. We are at the hour mark. So in about a half an hour, we'll take a break, and then we will go, and then we'll come back and we'll continue on. There are 4 other resources that I want you to be aware of. All of these resources are actually in our workshop document down here in the bottom. But now that I opened up this document, I do want to point out, right? If you want to connect with me, right? There's lots of ways to connect with me. So my page, my web page, and most of my resources end up there. I'm not a web designer, so you'll see them not as organized as I really want them to be, but most of the resources will end up there in some form or fashion. From there, you can sign up for my newsletters. We'll send those. I don't send those out as often as I should. I hope to do that better going forward, but that'll show you when I'm going to do workshops. Anytime we are trying to put together a bunch of resources for instructors, so it'll be the best way to find those or be aware that those resources exist. So sign up for the newsletter if you get a chance. I do have a YouTube channel. I post a ton of my course material that I use. In fact, like this last week, I did some server labs and I post them out there. And then like the labs from today, this week will all be there. All of my labs that we did, like if you want to see what we did 2 weeks ago in the CIS topics course, then all of those are there as well. So, that's one of those typical, right? Subscribe, like, comment below, hit the bell, all that kind of fun stuff, right? So do that there. That's where I post most content is going to be on my YouTube channel. I do have a LinkedIn if you want to connect with me. As I travel around, I would love to stop and have coffee or lunch or a snack with you. So my wife and I spend a lot of time in the RV, and we travel around the country. We do a lot of thrifting. My wife has an eBay store, so we tend to do that a lot. So I think if you saw in the comments at the very beginning, we're going to be in Las Vegas next week doing some thrifting. So it's nice when MGM comps you some rooms. Just go hang out for a couple of days and do that. But yeah, I would love to meet with you as I travel around the country. I know this the rest of the summer, I know we have Vegas, we have Frisco, Texas. So I'm going to be in the Dallas, Texas area. So if you're around Dallas, and if you are there, if you're coming to the lab, and I think like Tony, you said you were going to be there, and I know if you like soccer, like I know the FC Dallas and New York City are playing that week. We have tickets to go to that, and then we're going to go to a Rangers game. So that's a Wednesday night, and then Rangers game on Thursday night. So if you want to hang out with us and do those kind of things, let me know. I think it'd be fun. And then I'll be in Pittsburgh the following week. So I don't think anybody's from the Pittsburgh area, but I'll be in the Pittsburgh area the following week. So, yeah, if I win any money, I can buy more pies or comic books, either one. I'm good with either one of those. The collection's getting bigger on both sides of the house, right? The Raspberry Pi collection, you should see my desk. It's ridiculous right now. But so LinkedIn is a professional way you can connect with me. But if you are if we're out and about and you and you want to meet up, let me know. More than happy. I do love visiting other people's the labs, the way they've set things up. So I'd love to kind of garner ideas from that as well. I am on Instagram, so my IT instructor, and then the YouTube, the list, right? The playlist for this session is the playlist for that. So so if you don't remember, you can go to this link here. All right. So those are just kind of the basic ways of connecting with me. Good. All right. Let's take a look at some other things. Raspberry Pi. So Raspberry Pi has raspberrypi.com and raspberrypi.org, right? .org, that's the original webpage, and it is dedicated to the learning and teaching side of the house, right? All of the learning resources are there now. And the raspberrypi.com side is for the hardware and the software, the documentation, right? More of the formal equipment side is going to be the raspberrypi.com side. Okay. So Raspberry Pi hardware. Kind of talked about, so it's not going. That's odd. Does it jump over to software? It jumps to software. Hardware. Oh, there it goes. Hardware. Okay. So hardware, I've already showed you this personal computer kit, right? So they've come up with this. They kind of tucked the Raspberry Pi into this keyboard. I believe, Mike, you use those quite a bit. I think they're pretty good. I think early on there was some weirdness, but I think for the most part, most things work on that device now. The only thing this device doesn't do is the Pi camera. Which, like Raspberry, with the release of the new operating system, kind of went away from Pi camera. Like you can still, and there's really nice cameras that you can connect using the camera connector here, but this one doesn't have that camera connector. So if you're going to do anything camera-wise, you're using a web camera, right? And usually OpenCV and some other software that you need to use. So it's just a different way of doing things. If you have these devices, you end up with web cameras versus Pi cameras. Pi cameras are super ESD sensitive. So kind of going back to the question way at the beginning, the cameras are the one component that we have to be super careful of because they tend to get destroyed rather quickly. I think cameras are the one thing that we had issues with. The most issues with is the cameras, and most people, because they left it plugged in and tried to unplug it or plug it back and plug it into the machine while it was running. So really not a good idea. The Raspberry Pi 4 Model B, that's the current version of the Raspberry Pi 4. It comes in 3 flavors. There's actually a 4th flavor, but they're not making it. There was a 1 gig version. There's now the 2 gig version is the base model, the 4 gig version, and the 8 gig version. The 8 gig version, or the Model 4 has some EEPROM. They do things with EEPROM now that they didn't do before. So if you have an early version of the Raspberry Pi 4, there may be some EEPROM things that you need to update, some firmware updates that need to be done for that. And then they have the Pico, right? So in the Pico here, we're not going to play with the Pico here this week. This is more like an Arduino, right? So it uses MicroPython. So I really like it from that perspective. We did play with this in the last lab. So if you want to kind of see how that works, I think it was what, it was all day Thursday. So the day 4, morning and afternoon, and then day 5, we played with the Pico as well. I like that instead of having, I'm kind of thinking, how do I, first of all, keep costs down? This is a, with the pins, it's an $11 Arduino type of device, and it uses MicroPython. So then my students learn Python from day 1 instead of learning the whole Arduino C++, C/C++ kind of thing, and then switching over to Python. We have MicroPython and Python, and they operate really similar. The syntax and everything is the same. So from an equipment standpoint, right, from Raspberry, the actual foundation, they have this keyboard, and then they have the Raspberry Pi 4s. Those are the current versions of things. There's also a Raspberry Pi Zero, which is, I have a Zero. So this is a regular Raspberry, and this is a Zero. So the current Raspberry Pi Zero is equivalent to, say, a Raspberry Pi 3. It doesn't have Ethernet. It doesn't have USB. Well, it does have USB. It has the micro connector here, and then it's got this little, I think, a mini HDMI. So we got to have a funky cable to connect it to video. You can buy them with the pins or without pins. I think I have some without pins in here as well. I like pins, so I don't think all of mine currently always have pins on them. They have wireless built into them. A lot of the reason why we use these are less expensive, right? So these with the pins usually cost about $15 versus the $35. They're not as powerful, but for what we're teaching, right? I think these will work just fine. There is one solution I want to try this week to get these to work, because you can, when we talk about software, we'll talk about the desktop version of this, which is actually an x86 version of their software. I want to try to run it in virtual and see if we can connect to this and access the pins through a virtual machine. I'm not 100% sure that we can do that. I haven't tried it before, but that would, again, lower my costs, right? So instead of my students having to buy, right, these $35, $55, and $75 versions, I can have them buy a $15 version. And then we have dual booting on our current setup, so they can dual boot and then plug one of these in and access it just like it was a regular Raspberry Pi. So some options, right? So that you just understand some of the hardware components that you have out there. This class is not really meant to be, a hardware class, but I wanted to make sure that you were aware of these things. And I can answer questions as we go through the week about hardware and different types of ways of connecting things and different types of ways of utilizing these things. Okay. I think did I just, okay, just minimize. Okay. The other thing I wanted to point out is they have, so there's the camera modules that we're talking about. They got a bunch of different components and pieces. I'm looking for, I'm a big fan of their cases. They pop apart. They're really solid. You can also put a fan in the case as well if you're having heat issues. I'm trying to find, here's the compute modules. Okay. So this is the next kind of, I don't know, evolution of Raspberry Pi, but this is the industrial implementation of a Raspberry Pi, right? It comes in these CM4, compute module 4, and underneath, I think that they show you the back of it, they have these little, there's 2 sets of pins, right? So there are, you can buy like digital displays that have those connectors on them, and you can plug in the Raspberry Pi into that, and then the display becomes the monitor for this compute module. And then the compute module, you can install, say, a digital display board software, and it then becomes an internet connected, digital display. Right? They can be used in all kinds of kind of industrial types of scenarios, right? There's even places where I've seen where they're starting to replace SCADA devices. But these compute modules they're basically a Raspberry Pi 4. They can come with anywhere from, I think, 2 gigs to 32 gigs on the board itself. and they're relatively inexpensive. I think the most expensive of these is like $75, and that's the 32 gig version. You can see because there's not a lot of ports and other things like that on these things. It does have Wi-Fi built in, but they're really neat as far as like where do we want to take the our learning process. You can buy this programming board here, and you plug in the module there where these two little adapters are, and then you can program this to program this device to perform a function, and then embed that function into another device. Right? So there's lots of cool opportunities. Here's digital displays using Raspberry Pis. Lots of cool opportunities that you have to kind of go into the industrial side of things, right? In fact, some of the articles that I did pull were how to protect edge devices, right? So using a Raspberry Pi as an IDS to detect anomalies on edge devices and fog computing devices. So in these kind of spaces. So again, there's a way to tie those things together, right? And always looking for a way to, right, take it from being like a hobbyist computer to being something where there's actually, there's Raspberry Pis. These Raspberry Pis is implemented in businesses and in IoT type devices all over the world. And then as you get more into more industrial applications, you get more into this kind of a side of the hardware. Okay, we can take that as another step higher. And this is, I got one of these is coming. I'm looking forward to this, but Turing Pi, this is actually an ITX motherboard. And these 4 slots here, you can actually plug in 4 Raspberry Pi CM4 modules. They have these little adapter kits. You plug it in to the adapter, you plug that adapter into the motherboard, and then you can access all 4 of those, including an NVIDIA Jetson. So if you have NVIDIA Jetson sitting around, or you buy the compute modules, there's a couple of modules that'll plug into it. But my goal with this one is we can set up a private cloud solution, right? And we can start to learn Docker and Kubernetes and containerization, which in my research for this class, there's a lot of configurations out there that are cybersecurity configurations for like capture the flag and cybersecurity, like labs for testing, where they launch all of the, like they will launch a web app in a container on a Raspberry, and then use that as a low cost solution for allowing students to test their pen testing skills and things like that. So I'm looking forward to maybe doing something like that, and that's based on these compute modules. The board itself is like I don't want to say $250 or so, and then you've got I think each of these boards is 10, so you got maybe 300 on the board, and then you've got 75 for each of those. So for less than, that's what, 150, about $600, you have 16 cores, 90. 64, 128 gigs of RAM available to you. You can connect hard drives and things to this. There's all kinds of really cool stuff you can do with it. So just as an idea, I throw it out there for people to kind of start thinking through how could they do things and how could they, like, again, take what we're doing to the next level, right? So from this webpage, right, this is the raspberrypi.com webpage is showing you all of the hardware that Raspberry Pi, the foundation, creates. There's a ton of other hardware out there. Lots of other companies. Probably Wednesday, Thursday, we'll do a specific resource section where we talk about just parts and pieces that you could add to the Raspberry Pi. This is specifically just what Raspberry Pi does. Okay. On this page as well, there's the documentation. So there's documentation on the hardware, the Raspberry Pi OS, the Linux kernel, all kinds of really good documentation. I have my students refer to this documentation constantly. They also have documentation on the accessories that Raspberry has put together and built. and they have documentation on the microcontroller, which is the Raspberry Pi, or any microcontroller that uses an RP2040 chip, which is the Raspberry Pi design silicon that's on this. Right, so they have all the documentation here on the raspberrypi.com website. Okay. The next piece, software. This is where I need you to do a little bit of work, right? Raspberry Pi OS, right? We're going to write an image to a Raspberry Pi or to an SD card later today. And one of the things you need is this Raspberry Pi imager, the very first item here. Okay, so on Raspberry Pi, I'm going to copy this out. Go out here and paste it. raspberrypi.com/software. I need you to download, if you have a Mac or Ubuntu or Windows, right? Download the whichever version you need of this Raspberry Pi imager. Okay, you just can click on the download button. It's an executable. Right, I'm just going to run. I've already got it installed. We're just going to run through the installation again. Right, so this will be the software that we use to image one of our SD cards later today. Question? The process that we used to use was a whole lot more complicated. So, Raspberry Pi did a really good job with this imager, and we'll go through that in detail probably right after lunch today. But you need to download that and install that. It's one of the items that we need for today. You do not need to download an image from this website. The imager will do the download for you automatically. And it's usually, for some reason, it seems quicker. I don't know why. However, there are lots of options, and I want to show you those options. You do not need to download any of these options, right? There are, there's the current Raspberry Pi OS, right? This used to be called Raspbian. It's now called Raspberry Pi OS. This version is based on Bullseye. This is the current version based on Bullseye, which is a Debian version 11. Okay. There's a desktop, which is a GUI, right? So if the OS with a desktop is a graspable user interface, there's a desktop with recommended software, and that's going to include like Mathematica, I believe. It adds LibreOffice and a couple of other IDEs. It's a lot bigger, right? Over 2 gigs versus 800 meg. So I don't have my students do this one, even though we do want recommended software. We have them add that software later after the fact when it doesn't impact the lab. And we'll do that same thing today. We'll do this desktop, and then we'll add things as needed. There's also a light version, which is a GUI-less version, right? So it's just a command line version. Okay. The software that, there's also, that's a 32-bit version. And that will work on all Raspberry Pis. That was one thing that Raspberry Pi has always done, is whatever their current release of the operating system, it will work on all Raspberries back to Raspberry, the very first one. Okay. They do have a 64-bit version of the operating system now. So if you have a 3B or higher, right, or any of the compute modules or a 02W, Raspberry Pi 400, you can use a 64-bit version of Bullseye. Okay, so there's got the desktop and the light version. They don't have recommended software. You have to add it later, which is easy to do. And then they have a legacy version. Okay, this is using OS, the Buster version. All right, so the version 10 of Debian. This is the version that we're going to use, right? The Raspberry Pi OS legacy version. So if you've kind of pre-done things and you jumped in, you did the regular Raspberry Pi version, you're going to want to go and redo your operating system to be the legacy version. And the reason why is this new version came out in April, and it came out earlier this year, but it has new libraries in it that aren't compatible with a lot of the instructions that are out on the internet currently. And they took away Pi Camera, and they took away a couple other things that we have found causes issues with some of our labs, right? So in order to make sure that the labs that we're currently using work the way they're supposed to work, we use the legacy version. So when we get to that point, right, we'll be looking for the legacy version of the operating system. Okay. This is just, they brought it back because there was some incompatibilities with the current version with older with things that were designed over the last, say, 10 years or so. And most everything works with Buster at this point. And then the last software that they do have is this Pi desktop. If you want to try to put a Pi desktop into a virtual machine using VirtualBox later today, you can download this particular ISO. Right? It's a pretty big ISO. It'll take a while. It's 2.9 gigs. But this is the Raspberry Pi desktop that works on an x86 PC or Mac. Right? So as long as it has an Intel or AMD x86, x64 chip in it, you can run this software. So this is a solution that I'm looking into doing in my classroom, putting this as a dual boot on my lab computers, and then having the students buy the Pi Zeros instead of a full Pi, in order to reduce some of their costs down. So that's an experiment we're going to try. So if you want to do that, you're welcome to do that, not required. Okay, that's the only one that you need to download if you want to download it for an attempt to put it into the VirtualBox solution later on. All right, cool. That's the hardware software side. That's the raspberrypi.com website. Hardware software documentation, that's going to be your big thing. The forums are here as well. All right, so kind of the more official business side of things. Okay, the raspberrypi.org website. Lots of good stuff going on here. They have a learning section, right? Where they have, this is, I will point out, right? A lot of the stuff on this webpage, right, obviously, if you can see from the graphics, are designed for younger students, right? Younger students. However, there are resources for instructors, right? So Teach Computing. This is actually British, right? This is a teachcomputing.org is a British. I'm trying to find, there's a piece of, I lost it. There's actually a set of new classes that are really good for instructors. I'll find it and make sure it gets there. The other thing though I want to point out is on the learn, here we go, explore our projects. I think that's what we're trying to do. Yeah, so this page here, I'm just going to copy this over here. And this kind of gets away from, not 100%, but away from the cybersecurity focus of what we want to do. But this is a lot of really good Raspberry Pi projects that you could easily modify into, a more appropriate, the graphic wise and things like that. But a lot of these, even though they have the more kid related graphics, are really nice projects that you can do with your students, right? And I do a lot of these projects with my community college students. There are some cybersecurity ones in here. It's kind of digging through them to find them. That'll take time, but I just want you to be aware of this website at this point. I don't really want to get into this website as far as we're going to use it to do something right this second, but there's a massive, huge amount of things that you can do with this, right? And there's lots of cool projects that you can kind of go through and try on your own and see where they apply and where they don't apply. Maybe add a little more sophistication to the project to make it more in line with a community college or university level course, or even a high school. Some of these are designed for high school, some of them aren't designed for high school. But the Raspberry Pi Foundation or raspberrypi.org webpage, super good for a lot of that. There's also, and I'm trying to find it, there's I'll find it later and show you, but there are some courses designed for instructors on how to teach a lot of these things, right? So if you're not 100% comfortable, there are some really cool courses for teachers. I'm going to write it down so I don't forget to get you the resource. So teacher courses. I know we have the resource on our last class, so I'll pull it from there at lunchtime. Right. So those are just be aware of those two web pages. Okay. Then the Pi My Life Up web page. If you've taken any classes with me before, you know I love this web page. It has a ton of good stuff. A lot of the labs that we're going to look at that are web-based labs we're going to do are going to come from this web page. So Pi My Life Up. That's on our resource page here. So I'm not going to drop it into the chat, but it's on the resource page there. So yeah, there's lots of good ones here. We will pick. I've already kind of picked out the cybersecurity ones that I think would be relevant for what we're going to do this week, but I want you to be aware of this web page, because if you want to do a project on the Raspberry Pi in any of your classes, you can probably come here and find something that would work in any class, right? They have lots of good stuff. For example, network tutorials, right? So zero tier, right? This is actually a virtual network. You can set up virtual networks between devices. So it's basically peer-to-peer encryption, right? Totally cool stuff. AnyDesk, right? There's syslog server, right? If you want to do some things with NFS, we've done AdGuard in a previous class. That's like it's like a Pi-hole AdGuard. They're both ad blockers. That's actually a decent security lab. UFW, sorry. It's uncomplicated firewall, right? Uncomplicated firewall? Yeah, uncomplicated firewall. VPN server, VPN servers. Asterisk, if you wanted to try to set up voice over IP running on a Raspberry Pi. It's just like the list goes on and on and on and on. There's hundreds of tutorials. They keep them updated. If there's a problem with one, you typically can tell them and they'll fix it usually rather quickly. I've had really good luck with it. I want you to be aware of this website. And this website is almost worth the price of admission. So this one's a really good one. And again, we'll reach back to that. These are like websites I wanted to share before this first break. This last page as far as resources are concerned is elinux.org RPI Hub. This is also on the documents list. Okay, I'll throw it in the chat so you have it. But this is a really good resource for the Raspberry Pi in general, right? There's buying guides, how to basic setup, beginner's guides. You get into the hardware, the software. Like it's really packed with lots of really good information. And they even point out to a bunch of different books that are available out there. I like to always go to the OS distributions to talk about like the flexibility of the Raspberry Pi. So if you look here, if you look on the right-hand side over here, this right here, starting at 2.1 through 2.51, all of those are operating systems that can be installed on the Raspberry Pi. And then down here, they've gone through and you have the link to the distributor and they have some information about all of the different, each one of them, like whether it's, is it ARM or not ARM, or right, whatever the case may be, but they go through all of these different operating systems, right? So things I'll point out, you can install Kali Linux on a Raspberry Pi, right? So that may be one of the things we try to do later this week. IP Fire, that's a firewall. It's a really robust firewall. My students have used it in my networking class to build firewalls. Once it's installed, it has a graphical user interface. So it's really similar to a lot of the other products that are out there. And it's a firewall built on a Raspberry Pi. You take a $35 computer and build a firewall out of it. I believe OpenWRT, is that what it's called? I'm trying to find it. I know I missed it. It's on here somewhere. But that one is like a software that I know that people have taken like old Linksys firewalls and actually flash the firmware, and they have OpenWRT, this one right here. So that's you turn it into a router firewall. There's also, I believe, I said we did Kali. There's another Pwn Pi is one, right? So this is a pen testing variant of Linux that you can put on a Raspberry Pi as well. Just a ton, right? So it's just tons of really good stuff. Just be aware of these things like digital signage, own cloud, right? So you can build your own Dropbox, right? Private Dropbox. Slackware can be put on, FreeBSD can be put on. I think they have, like, so if you want to do retro video gaming, PyMame can be put on there. I'm drawing a blank on the main one that's normally put on there in my mind. I'm looking for it here. You can see like V2 Cloud, that's actually a thin client. I'm curious to try that, like in the sysadmin setting. It's supposed to, my understanding was it's supposed to be able to, you can use a Raspberry Pi and it'll present a Windows desktop that's running on a virtual machine in the background, like some totally cool stuff. So this is a good place to start exploring, right? There's lots of really good stuff out here that, again, rabbit holes upon rabbit holes upon rabbit holes is what I've found with Raspberry Pi. There's so many possible things, and it's just a matter of you looking at what makes the most sense for me and what makes the most sense for me to show my students, right, or to have my students do. And the idea here is that not just cybersecurity, but you can, any CIS course, a Raspberry Pi can be implemented into that and teach some of the, at least one of the topics, but probably more. But those four are the kind of my go-to starting point when it comes to Raspberry Pi information, right to the source, Raspberry Pi, right, .com, .org. For tutorials, I love Pi My Life Up. And then for really good, just a collection of information about the Raspberry Pi that you can see by all the hyperlinks how easy it would be to just rabbit hole all day long, and just get yourself kind of buried into all kinds of really fun, nooks and crannies of the Raspberry Pi and about the Raspberry Pi and all that kind of fun stuff. All right, cool. So those are all the resources that I wanted to share today. That's just today's resources. And we did talk about the class and kind of how the class is going to roll. I want to take a break here in a second. When we get back, I want to talk about the Cisco course. We'll spend the rest of the morning talking about the course itself. We're not going to go through and teach you the course or do anything like that, but I want to show you what's there. You're welcome to utilize the course. I have it opened until the end of September, I believe, somewhere way out there. So it gives you plenty of time to explore it. We are going to use the course for the labs, right? So, but I want you to be aware of the resources available in the course, because there are some really good things that we're not going to cover this week because they're not Raspberry Pi based, but they are cybersecurity based. So we'll cover all of that kind of stuff in the section right after we get back from break. So we'll do that. So we're going to take a break. We're going to come back. We'll go through the course itself, and then we're going to start to install all of the tools that we're going to need. So we'll get that kind of started. And then after lunch, the goal for after lunch is to go through and get 2 operating systems up and running. The PL app operating system running on one Raspberry Pi and a Raspberry Pi OS running on another, and then set up VirtualBox on your laptop PC, whichever computer you're going to use to connect to your Raspberries, and get, I think we need to get Kali Linux. There is a OVA that's provided by Cisco for that, and then Metasploit. I think those two, at a minimum, those two, and then possibly the Raspberry Pi desktop. So the afternoon will be, we're going to set up the lab, get all the operating systems where they need to be, right? And if we have time, we can just kind of move on to labs. But my goal is, it'll probably usually take us that amount of time to get all of those things for everybody perfect, right? And then that'll be today. And then tomorrow we're going to jump in. We'll do resources, and then we'll jump in and do labs. And then we'll do resources in the afternoon, and we'll do labs, right? And that'll be the modus for the rest of the week. So let's take a break, because I can just keep on talking. And let me write down one thing here to remember when we get back. On the screen, I do leave the recording running during the break, because if I turn it off, which has happened, I never turn it back on, which is bad. So 10-minute timer. 10 minutes good. You want to do 10 or 15? Usually 10 is a good enough time. Let's do 10. All right, I'm gonna mute and do all that kind of fun stuff, and I will see you right back. If you have questions in the chat, I will answer them when I return. All right, see you in a bit. All right, welcome back. Hopefully you came back. It's always my fear. First break, I'm out. All right, these 4 pages are in our document already, and I did not. You have access to the Gmail or to the Google Drive, and that page is also in our list of pages. The one thing I don't think PyTop, we talked about PyTop. So we just I want to throw that out. I don't like make sure you guys have all of those, whatever we talked about, because it'd be just kind of random things, right? Random thoughts. So PyTop was one of them, and then I believe Turing Pi was the other. I'm excited to get one of those and see how it works. I think a lot of that's because I saw, as I was doing this and getting ready, I was like, there's a lot of container, like a lot of people building Docker containers that they can deploy on a Raspberry and do, like I said, capture the flag and a bunch of other stuff. Some really cool stuff. Okay, so that one and that one. Those are the 2 that I remember. If there's something else I missed, if somebody can drop that onto that document, that'd be great. So I don't have access to, I don't know why I don't have access to the polling. We tried to figure that out earlier. For some reason I don't have access. So, so what's the best way to do this? I think we'll just do something like this. Actually, it does. Is that missing too? I think it is. Okay. Okay, so to help guide me, if you can just answer in the chat, right? I need you to answer this question in chat, right? So this is the first question. All right. So kind of where do you feel you're at with the Raspberry Pi? And honest answers are the best answers, because then that helps me, you know, what I need to do, right? Where I need to concentrate on, right? Cool. All right. So that's good. So most are in the middle, right? Which is kind of the expectation. That's great. All right. Awesome. Right. So, and I'm only going to go on whoever participates, right? If you don't participate, you can't modify anything for you. So same thing I tell my students, like if you don't want to give me the answer, I'm not magic. I can't adjust. So then the next one, right? So how would you rate your command line skills? Because a lot of things seem to need somebody familiar with that, right? Good, good. All right. Linux. And we won't get into PowerShell in this one. All right, awesome. So that's good. So a little bit higher there, right? So most people are familiar with command line and done a lot of things there. So you'll see a lot of these projects, a lot of these tutorials and things like that will have us doing stuff at the command line. And most of the time they tell us what to type. So it's not like you need to have a great, level of skill, but it's nice to kind of know where everybody's at to get, to make sure that we include anything, tutorial wise that's needed. So the next one is kind of Kali Linux, like the tool sets that are there, right? Who's comfortable there, played with that, not played with that, not ever seen it, don't know what I'm talking about. All right. So most is on the lower end. So that's good because honestly, that's where I'm at too, right? Raspberry Pi skills, I would rate pretty high. Command skills, I'd be, middling, right? I would say 6, 7 for me. And then Kali Linux tools, like I've played with some, mostly doing these labs. So but if I were to sit down and try to do something from scratch, I would be lost completely. So I'm kind of in that, yeah, there's a ton of tools. Like, so the main tools, like I think of Aircrack and Nmap and like I want to say the basic set of tools, like not all of the crazy tools, but just the idea is like a sense of, if you played with Linux and you can get around with it and without any kind of, with any help and be fairly comfortable, that would be kind of that'd be in the high scale. If you've seen it and you've done some of the commands and you kind of know where things would be, sort of, then that's kind of middle, right? Yeah, so those kind of things, right? Those are the big 3 there, right? Cool. So it seems like, right, I think Raspberry, the skills are kind of all over the place. I think Linux seems to be, hovering at 5 to 7 range for the most part. And Kali Linux tools are going to be that 3 to 6 range for the most part, right? So that's fair. This one will be hard to keep track of, but we're going to do it anyway. So what topics do you teach? Like, so, right, as instructors, what are you teaching? Let's go IT, awesome. Networking with cyber, cool. Yes. Love it, love it. All right. So John, is that what you teach? That's awesome. That's I love that. A little bit of everything. I tend to be a generalist, right? So I teach a lot of different things. Yes, I agree with you. The rest is details you can look up. I love it. Love it. All right. Awesome. Good job. Cybersecurity. So lots of networking, which makes sense. A handful of cybersecurity. So some cloud in there, a couple of clouds in there, some Linux. Nice. All right. Cool. So a good range of things. So the next one, next one's going to be hard. So try to keep the next your answers short, because otherwise I'll never get through this one. But I really want to know, like, what do you want to get out of this workshop? Like, what would make this, in your mind, a successful workshop, right? And if you can kind of boil that down into, a phrase, a smaller set of words, something like that, that gives me a sense for what I need to be trying to achieve. What do I need to, right? So hands-on projects, good, fun, hands-on, good and fun hands-on project. Good resources to implement Pi, projects in the classroom, okay. Projects for IoT, okay. Project for basic security, awesome. IoT projects, all right. Ideas on using Raspberry Pi for classes. All right, labs to add important concepts, awesome. Love it, love it. Good, I think I'm on the right track then. I think what I have planned is cool, all right. So some of so pen testing, some of the reason why I want to implement some of these labs from the IoT security classes, because they actually are more pen test related, like they are practical, like here's what we're going to try this, you know, and show you how it's actually done, versus a lot of times the students know they've been told about things, but they haven't done anything. So good. All right. So that's good. I think that helps me. That helps me know that I was on the right track. And I think with this, though, I can make sure that we guide our learning to meet these goals. That's awesome, right? And it looks like the last question I had was like, is there something specific that you have that you want to learn? But it looks like the list that we have here, I think, is going to be sufficient for me to make sure that we have things in place. So we are going to do, right? My goal using the Cisco material is to kind of do some of that pen testing, right? Because they have some really good labs in there for that. And my goal for using a lot of the web resources is to show, like from a security standpoint, like the defensive side, right? The firewall side or the VPN side, or you know, how hashes work and things like that. So kind of a mix, right? I want to kind of, you know, cybersecurity is a big world. In fact, I even wrote down one of the things was to do a web camera, right? And the reason for that was like, well, a web camera would be like a security device, right? So like I want to do, I've actually been thinking for my IoT class of having the final project, have all those students build a server room monitoring system, right? Maybe sound, maybe video, maybe temperature, humidity, like some of the, you know, those kind of things, like, you know, build out a practical system administration IoT device. So I think that would make some sense, like from a physical computing standpoint. So physical computing or cybersecurity, physical security, two projects that I pulled as potentials were that just a web camera, like a streaming web camera, right? The other one was potentially like maybe facial recognition, right? So if you wanted to do an access key or an access lock or something like that, it was based on facial recognition, and maybe doing that. That one maybe a little bit more intense, maybe too much for what we're doing this week. But that was kind of the thinking, right? So pen testing, like actually physically doing some cybersecurity pen testing types of things, and then also like working on understanding VPN, understanding firewall, understanding you know, maybe monitoring, like syslog, things like that. So try to wrap all of the components of cybersecurity into what we're doing this week. Okay, so good. I think I'm happy with those answers, and I'm glad that I'm on the right track. So I think I can take what I've got already put together and we can make it work. Awesome. Okay, good. Let me put this out of the way. Thank you for participating and helping me gain a better understanding of what it is you're looking for, right? So that way then I can deliver. Like, I want to make sure that I deliver as best I can. Okay, so what I want to do now is I want to take a look at our course here. This is the Cisco course. Oh, it's been so long. We need to log in. So this is the base Cisco course. It doesn't have any modifications to it. If you've taken any of my previous instructor training courses where I did this course. I heavily modified these courses. But for our purposes this week, I left it strictly as the base course, okay? Again, a reminder, this course, you do not have to be certified to teach it. However, it probably is a benefit to take the certification, the instructor certification course to have time to practice and be good at it. The second part of this is that this course officially ends next July. So I know I'm repeating myself this time, but I am working on personally trying to make sure we pull these labs out so that they're available for use in other classes. So with that being said, this is a really, I don't know, I really like this course. It's a good course. I'm going to jump over to the contents of the course, right? So if you guys have never done that before in a Cisco course, I'm going to go back and close that. Right, I just usually click on like one of the reads, and then from here I go to the course index so I can get to where I need to be quickly. So the course has, I think it's six chapters, right? The IoT under attack, so it's kind of explaining IoT and the goods and the bads, right? Because there's lots of goods and lots of bads about the IoT, and kind of giving us some basic understanding of like the NICE cybersecurity workforce framework, and those kind of things are kind of in this initial chapter of things. The other thing that's in this initial chapter of things is setting up the Raspberry Pi, right, and setting up the topology for the course, right? And then they do throw in a couple of other labs that I really like. I'm going to click on Lab Index here. I think if you haven't done, and if we have time today, I have the Shodan Shodan Search Lab to do as a group, right? If we don't get to it today, I highly recommend that you take a look at it tonight. It's not very long, but it is really eye-opening. And I think that's the one thing I'd like best about this course, IoT security courses. I feel like it's really an eye-opening course. Like when students do these labs, right, and they physically connect a serial port to these pens and able to get a terminal session on a computer, like that's a whole lot more impactful than me doing SSH and type, and get it connecting to a terminal, right? And maybe I'm wrong about that, but when I see my students do it, like I think I have that. That's just, I don't know, that's just how I feel about it. I think it really makes like what just happened, right? The second, and then Shodan, when they go through this, it just has you do a couple of really basic things, but once the student starts to see, holy cow, the amount of information that's available online for a hacker to use to do something nefarious is ridiculous, right? And that one simple exercise, that search exercise, will, it's illuminating, I think. It's one of the reasons I like this course so much, is that I think when you get done with these labs, like the students are like, what just happened? Like, what did I just do? Like, I just did that? Really? Are you kidding me? Kind of a thing. So I really like that lab. The other labs have value, but then we will do 1231 and 1232. We'll do those this afternoon. And then depending on timing, we will do the harden a Raspberry Pi and investigate vulnerability assessment tools. We'll do those either later today, if time permits, or we'll do those first thing in the morning. I have them on the schedule for first thing in the morning, right? And again, that's where time is flexible for us. And usually, I always go in optimistically, but we always usually push stuff, right? Because we always we either get sidetracked and we're doing something else that's interesting, or we take too long, it takes longer to do something or whatever. But in the first chapter, right off the bat, we show them Shodan. We have them do, there's some other, like this evaluation of recent IoT attacks, evaluating the IoT security risks. Like there's some research right? There's several research assignments in the class, which again, I think is right on task with a cybersecurity professional, right? It's not all about, Mr. Robot, right? Right? To get to the point where you're skilled enough to do that, like you have to do the research. And if you've ever watched Mr. Robot, have you guys watched Mr. Robot? I really enjoyed that show. They throw some stuff in for shock value, but the most part, like I love the way they approach the hacks and the social engineering components, and they show like really, then they show like tailgating, right? And then dropping off a USB on a table and somebody just randomly grabbing it, throwing it into their computer, kind of a deal, and instigating a hack from that perspective. But they do a lot of really cool things there. But they allude to or show you that there's a lot of pre-work that needs to be done when it comes to being a cybersecurity professional. And I think students tend to have this fantasy that if I'm a cybersecurity professional, man, I'm gonna just be hacking all day long. No, you'll be researching 90% of your time and pen testing the other 10% of your time, and then evaluating what you pen tested the rest of the time that you have. So I like the fact that they kind of throw these research pieces in a couple of places to just again open the students' eyes to this world of cybersecurity. Okay, so that's the plan for the first chapter, right? Just introduce the IoT, introduce that the positives and negatives of it, talk about it from a cybersecurity standpoint, and then at the very end of the chapter, right, let's set up our topologies so that we can do the rest of these labs the rest of this semester. Okay. Now, the other thing that they also have, which we'll talk about this one time, but I really think you should take a look at it. And in fact, I would almost encourage you to, because they're packet tracer labs, like you could pull those out yourselves and run these packet tracer labs. But what they've done with this this course is they start in chapter 1 and they introduce a smart home, right? And I don't know if it shows us a picture. Yeah, so they introduced, this is a smart home, and this is actually built into a PowerShell or a packet tracer lab. And I don't know if they're going to remove the IoT stuff from packet tracer or not. Does somebody know that? I thought I heard a rumor about that. Right now, they have all of these different really cool IoT devices in packet tracer, right? Or they had them in packet tracer at one point. And they've built this, right, really relatable set of labs, right? Because every student understands a house, even if it's an apartment. They understand the concept of a house, right? They understand the concept of heating and cooling and having a fan and a TV and a smartphone and a coffee pot. And they all understand those things. Like, so we're not giving them concepts that are unrelatable, right? So I really like this from the standpoint that we're giving them a relatable scenario, right? And then throughout the entire semester, right, starting with chapter 1, got to go back to my course index. They introduce it in chapter 1, and then once we start getting to the device attacks, the communication attacks, the application attacks, we look at the same model, the same house, from the perspective of physical device security. And we look at it from communication level security, and we look at it from application layer security. So you're looking at the same scenario, right? You introduce it, you look at it 3 times from 3 different perspectives, and then at the end, you actually do a risk assessment on the network, the smart home network in a house, okay? Again, all of it's relatable because the students can understand, or we're not giving them, a manufacturing floor with SCADA devices and all the other things going on where they have to imagine these things, right? They've all lived in a home. They all have seen a ceiling fan. They've all seen, right? They've seen these things. They understand these things. And we're just using that as a model. So I really, really like this idea, but they go through, this is actually a vulnerability and threat assessment assignment. And it starts at the very first chapter and goes all the way to the very end of the book, right? Or the very end of the semester. Totally, I don't know. I really enjoy it. If you can't tell, I really think it's a really good, good set of labs, right? Into chapter 2, we talk about IoT and system architecture, okay? They do have you do this one lab, create an IoT sensor actuator. That's a really fun lab. It's a really neat IoT lab. I wasn't planning on running it this week. However, I think there's enough people that want to do an IoT lab that we will probably look at this. But what this is we're going to set up 2 LEDs on a Pi, and we're going to connect the Pi to a service called dweet.io, which is connected to IoTTT, which is connected to your cell phone. Your cell phone, you actually have a button, like you're going to create an icon on your desk, on your phone, that's a button, and you're going to press the button and the lights are going to change. Right? The reason they do this exercise in the chapter is to show you, or to show the students, and if you come down here, they go through the whole process, but the questions at the very end are what's important about this lab, right? And they're like, yeah, that's not very exciting, but let's talk about the security of this. Like literally, you look at it, there is no security at all in this piece, other than I think maybe some access tokens for IoTTT. But a lot of it is just like flat out, like it could be attacked left and right. So this it's meant to show the students the security vulnerabilities, right? But it is a really cool IoT lab, so cool that I actually have moved this lab into my IoT class. So I use this lab in the IoT class. Because I really like the fact that they physically touch a button on their phone and something happens on the Raspberry Pi. Okay, so it's a pretty cool lab, IoT lab. It wasn't on my original list. However, based on the responses, I think we may add that one back in for that purpose, right? Just to have an IoT security related lab, and then another investigation lab, right? So the first 2 chapters of the book set up the IoT, right, and all of its potential problems from a security standpoint, right? Then we go through the different architectures of IoT, and then we get into the device layer. So we're going to now take the Raspberry Pi that we have, and we're going to say, how can we attack the device layer, right? And then chapter 4, how do we attack the communications layer, right? We have chapter 5, how do we attack the applications layer, right? So those 3 chapters, right? That's going to be the core of the, quote, pen testing components of the lab, of the course. We're going to compromise the device hardware, right? So that's where we're going to physically connect to the device and connect to the terminal session. Then we're going to turn that off, right? We're going to show you how to secure that connection. Right? So not only do the students hack that component, but then they secure that component, right? So pretty cool stuff. And then there is a lab that uses the, I want to say it uses Kali and a firmware file to attack or compromise device firmware. So we show some firmware issues there. There are some, how do we get that file in the first place questions, but we do that, we have a file and we can actually attack it. So we spend chapter 3 attacking the device layer. So we're going to try, I have slated for us to do the device hardware and the device firmware. And you can see there's another investigation lab as well, right? So, first 3 chapters, 4 different investigation labs already, okay? Chapter 4 gets into layer, the communication layer. So we're going to sniff some Bluetooth, right? We're going to connect some things to the Raspberry via Bluetooth. We're going to do a port scanning lab and then packet crafting lab, right? So, right, lots of cool things at the communications layer. Again, giving the student a taste of the actual pen testing / hacking that needs to be, that happens in order to make those things, to make these things happen, right? To port scan properly, to packet craft properly. Okay, so pretty cool stuff going on in chapter 4. Chapter 5 is all about the application layer. Okay, so they're using Openvas for vulnerability assessment. So we get into start talking about vulnerability assessments. Okay, this lab we're going to attempt challenge passwords in Kali Linux or with Kali tools. We're also going to look at the web application vulnerability lab. I don't know. I need to look at the notes. I thought there were some issues with that. We'll check. I like the hacking MQTT lab. However, that lab stopped working when we get to the encryption component. So there's something different with the libraries that don't allow us to encrypt the files. Like we had a 100% failure rate on the last 2 steps of that lab the last time we tried it. That lab, we're not going to do that lab here. And the only reason we're not going to do that lab here is because it requires 3 Raspberry Pis. And normally, if we do this in the classroom, we set up 3 students, right? One with the publisher, one with the broker, and one is the subscriber, right? Those 3 pieces. Now, there is a lab on setting up Mosquito, which is MQTT on your Raspberry Pi that I did find online that maybe we can try that one. It doesn't require us to have all those pieces. And I don't know that we'll encrypt it. Right? And I think the whole point for that lab is to show you if you're using MQTT, which is an IoT protocol, right? It's not a common protocol unless you're running an IoT. Sorry, start to mix up all the acronyms after a while. It shows you that by default, it's an unsecure protocol and there's ways for you to secure it, right? That's the idea of that lab. So there are other ways of doing that lab that I think would be really good. And in fact, I do have it as a to be determined lab in my IoT class because I really would like them to see one of the IoT specific protocols functioning, right, and have them, have the students work together to build, an MQTT solution. So we won't do that one here. I wasn't planning on doing the UPN one either, as far as the labs are concerned. On this chapter 5, we're going to look at these 2: challenge the passwords and the web application vulnerabilities. When you get to chapter 6 of this book, of this course, right? Now you've done the first 2 chapters, introduce the IoT, talk about the IoT infrastructure, how it all comes together, what's good and what's bad about it from a cybersecurity standpoint. You go through the hardware, the communications, and the application layers, and you give them, concrete labs that show vulnerabilities, that show how, techniques for hacking each of those, or pen testing each of those particular components. You get to the very end, right? And remember, all along the way here, we've got these packet tracer labs off to the side of the they kind of go in parallel, but you're doing similar. You're thinking about similar things, right? The labs that we're doing, the hands-on labs, you're actually doing pen testing stuff. And then the packet tracer lab, you're thinking about the vulnerabilities and the risk associated to communications level, application level, device level, right? And now that we're into chapter 6, right, they bring up CVSS, they bring up DREAD, and they actually have you do a risk assessment based on that packet tracer scenario that you've been working on the whole time. So not only do we show each of the levels, like each of the levels of attack surface, right? We also look at the risk of each of those attack surfaces, and then we have the students build out a risk assessment of that scenario that they've looked at the entire semester, right? So I've really enjoyed this course. I think it's a really good course. There is a blockchain demo at the very end. I don't know that I've ever done it. I'm sure somebody here that's taken the course has done it. I don't think I have done that one. But that's the course in a nutshell, right? Again, this wasn't about us doing the whole course, and going through it in great detail, but I do want to kind of point out how it's built, what I think is good about it. I think there's a lot of really good stuff in this course. I really hope that they come up with an alternative solution for this one. If not, I'll be yanking all of this stuff out to use in other courses, because there's such a good set of things that students are doing in this with these labs and with the material. All right, cool. Any questions on that at this point? No, we don't have NetLab here. Not that I'm aware of. We might have it. I stopped teaching the Cisco networking stuff. We brought in a new instructor who was really good at it, and she kind of took over everything. so which is okay, because I'm the server guy, so it was hard to do both. I don't think we have NetLab. I know we have some new stuff that we're doing in there, but we haven't done anything into NetLab. So that does bring up, thanks for reminding me, without knowing that you were reminding me. There is, close this. Let's go back to, we'll go to resources, course resources. And I believe all these, in the IoT security class resources, there are two other things that I failed to mention. There's a capstone that's built into the course. Okay. And what they had you gather baseline information, do MQTT, additional running services, remove rogue users, right? So they have a setup where you go through, right, and show all of the cool things that you learned this semester, which I think was totally awesome, right? It's like a final project. So that's built into the course itself, right? And then the other thing, which is more the answer to, or not the answer to your question, but something else that kind of got me thinking, the Cisco IoT security game. And then was it you guys that were trying to do the security game? Or am I thinking wrong? I thought somebody was trying to do this game.
We just did the connections course once.
Okay. So this one is, let's take a look at this real quick. So, and I have not run this, so I don't know if it works or not, but I really think this is something that I have put on my list to do. That we have a lab tech that helps me with a lot of these things, and I'm looking at rack mounting a bunch of Raspberry Pis and possibly creating this this system as part of that, and then having it where they can fire up, students can fire up a Raspberry Pi as a web server or whatever, right? We can, they can launch these things on these, basically make like a cloud computing type of solution with a bunch of Raspberry Pis rack mounted in the rack. But this game, right? So you've got an internet connected Raspberry Pi, and then they've got cloud service simulator, game controller, you got your PC as the instructor, and then each team has a Raspberry Pi with their PC connected with Kali Linux, right? So any number of teams can do this, or you can just have, Raspberry Pis, and it could be a single person, it could be multiple people, but it's like a capture the flag game, right? Where there are 10 missions, and these are the missions, right? And they go through and they discover the secret flag, and then they write down whatever the secret flag is, for the, to turn in that they found, they were able to solve the problem or solve the solution, right? And you can run it as a competition, right? So everybody starts at one time, and and the first team that gets it gets the most points, and then the next team. Or you could, have it there available and students could try at any time, right? And the goal would be not to race other people, but to complete the entire set yourselves, kind of a deal. So I have not played with this, and I really, if I don't do it this way, there is, I want to say there was an article that I was trying to get back to I believe I had found an academic article that had something similar to this, and they were using containers to fire up web apps for students to attack those, to do pen testing and capture the flag type stuff. So I really think there's I don't know how to do it at this point, but I really think in my mind that in fact, I know that there's a way for you to set up like a bank of Raspberry Pis with containers that would allow you to have this kind of a capture the flag setup. So you could teach the topics in class, have them do labs in class, and then they have to do it for real against this set of Raspberry Pis sitting on the network. How to get there from where I'm at this, from where you're at to there, I don't know yet, but I think this may provide a good blueprint for that. And I'm glad somebody brought up kind of the NetLab, because it just reminded me that this thing exists. But they would basically go out, and the students would go out and have to, they would have to set up and connect to their, connect to the game, and then they would then try to find a way to find these problems, right? Figure out how to break, how to solve each of these 10 missions, right? So the 10 mission deal, which is right here, I kind of highlighted it. And I think in the student guide, tell you what's going on. And then I believe, here's the resources, how to set everything up. And then, then they kind of walk through, there's this map that they walk through, and they have to, like, once the mission is flagged on the game board, then they follow those instructions that walks them through at least part of what they need to do. And then they would solve each of the problems, and it would record whether or not they solved it properly or not. So that is a whole set of stuff here. I've actually, in the IoT security class resources, there is this IoT security game resources. It includes the setup guide. It includes the templates. It includes the zipped files, which are the operating systems for the game controller, the WebPi, and the end devices. Okay.
Kerry.
Yeah.
Is that part of the course that the game is?
It doesn't show up in the course, but it's resources provided with the course.
Oh, okay.
Yeah, they don't. In the course, there's no reference to it at all that I'm aware of. Right? It's a security game right there.
Oh,
and
okay.
There's the capstone and the security game.
Okay. Yeah.
And then this kind of shows you the missions. Like I don't know why I haven't done this yet. I just, every time I look at it, I'm like, I should do this. So it's just, I think there's time needed to get it set up in the first place and make sure it's going to function. I have a lab, and my lab is a sandbox. So I could actually set this up and leave it on and not ever have to, not have to mess with it, but then students can come in and actually try these things on their own, right? So I don't, I would want to, depends on how you want to do it. I mean, but it's, I don't know. I'm excited about it. Obviously, I haven't tried it. I think it doesn't, I don't think it doesnn't sit on Net Academy or NetLab. And I don't know if somebody's tried to convert stuff to NetLab or not. I don't know. I don't have it available, so I immediately just kind of go through, how do I make this work on my own machines? So most of the time when I convert something from a Cisco PL app to a regular Raspberry Pi OS, I have to go through and figure out what libraries are needed and make sure I have those libraries. We change, and usually only have to change like in the imports, because a lot of the imports are to specific pre-made libraries, and then I have to change. You have to change coding sometimes, The labs that we have converted, some of them required us to change massive things, and some of them didn't require. What I usually did is found alternatives, right? An alternative that did the same thing, using already, a different set of tutorials. There's not a lot of tutorials that I know about yet, like that, like especially like the command line serial. There may be. I haven't looked for that one specifically because I really like the one that's in here. If I already have one, why would I go look for another one? Now I may have to look for one because of the fact that this is going to not be available after a year from now. All right. Yeah, I think so. I really think setting up a Pi would be a great like a VM. And I think I want to do that today. That's why I downloaded this desktop version, because I want to set up the Raspberry Pi, the VM there, to try to see how that would function. All right. Any other questions? So Netacad or NetLab, no, not that I'm aware of. I think, yeah, I really believe VM would be awesome for that. Let me get this out of the way. All right, so then we have a set of stuff that we need to, and you just have to forgive my scratch writing here. It'd be so much better if it was typed out, but it isn't. So what I want to do now, if you have additional questions or something comes to mind at any point, right? Obviously, you can put it in chat. You can send me a message. You can write me an email, right? Any of those kind of things. If I feel like the answer would be good for the whole class, like if you send me something in a private message or something, I have a tendency to answer questions to everybody. I won't mention who asked the question, but I'll typically, right, I'll try to share as much as I can with everybody. But, so there's a set of software that we want or need. And let me kind of go through this real quick so we understand it, and then I'll walk you through a lot of the pieces, right? So to do the Cisco labs, we're going to need the PLApp launcher there, okay? And I'll walk you through that lab in a minute. We're going to need the PLApp image. So there's an image that we need to download. And as soon as I'm done going through this list, we're going to go to here and download that image so that we can get that done out of the way. I've already talked about the Raspberry Pi Imager, and we did that installation earlier. There's another piece of software that I like to have available. It's called SD card formatter. And I'll take you to that website. We'll copy the website into the lab. It is the SD card formatting software from the SD card foundation. I think it's foundation. SDcard.org, right? They're the ones responsible for the standardization of SD cards. I like their formatter a lot, right? So I like to have it. We may or may not need that's putty, if you believe me, right? Wow. When you look at your own writing, you're like, what are you talking about? It's putty. P-U-T-T-Y, right? So putty or Terraterm or whatever, something like that. We may need that, we may not, depending on how we connect. But I think most people who are network instructors already have something like that on their machine. We can SSH from the command line in most cases. We are going to need VNC Viewer, right? So if you want to connect remotely to your Raspberry Pi and not connect it to a monitor, then VNC Viewer would be needed. And when we get to the Pi Imager, right, we'll go through all of these pieces here. And then the final piece is Oracle VirtualBox, right? And then there's two OVAs, which when we download this image here, we will start the downloads for these two, because I think Kali is beastly. It's really big. It takes a long time. But we'll download those two OVAs and we'll fire up VirtualBox, which is a hypervisor, right, that we can run on our computer. And then we'll run virtual machines for Kali and Metasploit. And then if you optional is the Pi desktop version. And if you download that, we will also put that in Oracle VirtualBox. So by the end of the day, we'll have the PL app launcher running on our machine. We'll image an SD card with the PL app image. That's the Cisco image that we'll use for the labs from Cisco. We'll use the Pi Imager to format. Well, actually, we use SD card formatter to format the SD cards. We'll use Pi Imager to write the SD card. And then we'll use these softwares to connect to our Raspberry Pi operating system on our Raspberry Pi connected to our network. And then we'll use Oracle Box and these other two to make a virtual machine network. And I'll show you the graphics and pictures on how that's going to work here in a minute. All right, so that's the plan. The first step would be to go to the course, our Level Up Your Cybersecurity Skills course in Netacad. And like I did earlier, I would just simply click on Read Chapter 1. I would go to Course Index. I would go to Lab Index, and I would go here to Chapter 1, Lab 1.2.3.1. This is the lab that sets this up. I'm going to walk you through how to set it up. So we're not going to worry about opening up the lab. You can open up the lab and follow through if you would like. It's really not overly difficult. What you do need is you need this image right here. So if we click on that, it should have taken us to a different page. That's not good. Hold on, let's see what's going on there.
Can you put the link, please?
Yeah, this is in the course. Let me get there. Click that, click that, click that. That is 1.2.1. Okay, so that's the. Okay, that's where it should have taken us. Okay, this takes us out to the IoT virtual machines page. I'm going to put the link there. This page has the PL app launcher for Windows and Mac. It also has the image for security. And then it has your Kali VM and your Metasploitable VM. Okay. You will need either, if you have Windows, you use the launcher here. And if you need Mac, you need the Mac launcher here. Okay. So I need the Windows one. So I'm going to click on the Windows one. It's a tiny, right? It's a tiny executable. And then this IoT security image, we're going to need that. That's going to be the image that we're going to write to the SD card for the Raspberry Pi. You're going to need the Kali IoT OVA. These take forever, so we're going to do this now, and then we're going to move on to some other stuff, and then we'll come back when these are finished. And then the Metasploitable, right? So there's two OVAs that we want to download. So I've got my Raspberry Pi desktop that I'm going to ISO that I'm going to turn into an OVA. I got my PL app launcher. I'm downloading my image for PL app. That's going to be the operating system that we're going to put on the Raspberry. And then these two OVAs, okay? This one is huge, like 7.4 gigs. This can take forever. So we're going to let it run, right? While it's running, I'm going to go back to our class. And I'm going to go to the next lab, okay? So I just want you to get these downloads started, right? And then we're going to go to the next lab, which is 1.2.3.2, so that we can take a look at the graphic that explains how this is going to go together, okay? And I don't even like the way they did that graphic. I thought there was a better graphic of that. There isn't a better graphic. Awesome. So what you're going to have then is on your, this is a terrible graphic. This is not even close to what we want to do. That's funny. Let me grab the whiteboard and kind of explain what's going on here. So they do two things here, right? So we need our computer connected to the internet, right, to get all of the software, right? To get all the software. And then the way they have this running is they have us disconnecting from the LAN, right? So if you're in a lab environment, like a classroom environment, you would have the students, their PC would connect directly to their Raspberry, okay? The reason why is because there's a point in time where we do a pretty aggressive scan of the network, right? Which would then be picked up by any kind of IDS as a potential problem. So we want to try to avoid that. So what we're looking at doing though, right? Because I was looking at having a PC here, PC or Mac, right? And on here, we're going to have the PL app launcher, the PL launcher, we'll call it. I can't write small with this little pen. So that's going to be our PL launcher. And then, right, we're going to have, let's have a network connection, right? Our regular network connection, right, to the cloud, right? So this is your regular network. Okay, and then from a USB port, right, we want to put that USB to Ethernet. And then we'll connect that to a switch, right? And then you connect your Raspberry Pis to that, right? So this would be Pi 1, would be Pi 2. This would be a USB to Ethernet adapter, okay? If you don't have a switch, right, you can just connect whichever Pi we're using at the time, you can connect directly to this, right? So you can just, instead of going through a switch, you do that. But this is the scenario that we want, because if we aggressively scan this side, we're not going to cause problems over here. But this is the setup, and that's why I asked for us to have this USB to Ethernet. If you're at home, you can connect these to your regular switch, right? And you should be okay, right? Unless you have an IDS on your network that's going to cause you issues when you do aggressive scans and things like that, port scans and things. If you don't have that, if you're on a school network, right, this is going to be the way that you separate yourself from the school network so that you can do whatever you need to do over here and not cause problems on this side. Okay, so this is kind of the plan for our connectivity once we get there. On my computer, I've got PL app launchers down, and the PL app image is downloaded. Metasploitable is downloaded, and Kelly is about halfway done, coming up on halfway, right? So a couple other things that we can do while we're kind of waiting for these downloads, we can go start some more downloads. Awesome, right? Go to sdcard.org. I will put that in the chat here shortly. Whoops. Go there. Copy this. Paste that. We'll add it to our list of things. This is, right, this is the SD Association. They're the ones responsible for all of the I just drew a blank on the word I'm looking for, but they are responsible for the SD cards, how they're created, what their speeds are, what their classes are, right? All of the work around SD cards is responsible. This is the group responsible. So they have, under downloads, they have a memory card formatter. They have one for Windows and Mac, right? So I'm on a Windows machine, so I'm going to click on the Windows download, scroll down and sign away my firstborn so that I can get this software, right? Because that's how everything works today. It's pretty small. You can see that it's already almost finished. So this memory card formatter, right? So once we get the executable there, it is, I like it because Windows, and this is a Windows thing, I think, but Windows, when you plug in a card that's already formatted as a Linux operating system, it will only see that first 500 meg of like a partition, right? It only sees that, and when you try to format, a lot of times it will only format that first part and skip all the rest of the stuff. With the SD card formatter, it sees the card, the total card, and it formats the total card. I've had very good luck with it. I have never had any major problems with it. So it came down as a zip, so I'm going to show in the folder, maybe. All of a sudden my computer's like, you're making me downloads, you're showing video, what are you doing to me? So I'm just going to unzip that folder or that file so that I can run that installation. It usually comes down as an executable, so this is kind of weird that we've got to do. That's the executable there. Oh, that must have been it. That's a change since the last time we've done it. So it's kind of going through the installation of the SD card formatter. I've already installed PyImager from earlier. Okay. And I'm currently installing the SD card formatter. I'll put the link to that page here. So it's in the chat. My Kali is almost done. So this one, I'm going to sign away my second child. Lucky I have the 5 of them, so I can get lots of lots of collateral. All right. While that's going, the other item. I wonder if we need anything else right now. Oh, we're going to need Oracle at some point. So, we're going to search Oracle VirtualBox. It's going in the background. Kali Linux is almost done. My installer stopped responding. My computer is not liking my do everything at once. So the link for Oracle VirtualBox is in the chat as well, as was the SD card reader, the Netacad, the link to the virtual machines VMs is there. I need to download this one. I'm going to cancel my install until I get done with these downloads. So what do we need here? VirtualBox Windows host. Grab that one. right, so VirtualBox is down. I think I got Kali's. So Kali's down now too, so that's good. So we got VirtualBox, which I put in the list. SD card formatter, that's in the list. From Netacad, we pulled Metasploitable, Kali, the IoT security image, and the PL app launcher. Those are all the pages. So the other thing, let's talk about. So, okay. I'm going through that list of things that we've got going on. Here's our list. Okay. So far, right? We downloaded the PL app launcher, we downloaded the PL app image. We also downloaded Kali OVA and Metasploitable. Okay, so as we go through this list, so yellow for me, just we downloaded. Okay, I also downloaded Oracle VirtualBox. I think that's on that list as well. And we downloaded the SD card format. Imager was done earlier. We downloaded it, and then that's installed. Okay. These other two here, I'm going to wait until the time where we need them. I did also download the Pi desktop. Okay. All of those links are in the chat currently. All right, so we got all those pieces. Now I'm going to, let's go to show all real quick. Oh, I'm going to go back to my so here's that SD card formatter. Now that I'm not downloading anything, go ahead and finish this off. It's a whole lot quicker when other things aren't getting in the way. I'm not going to launch the program, but I did get a new icon on the desktop. So there's the two, Pi Imager and SD card formatter. Those are the first two pieces. If I go to my downloads, I should have had, go date modified. I should have the PL app launcher.exe. So I'm going to click on that. That's going to give me the Cisco PL app launcher. And this will be the software that we use to set up the Cisco software. All right, so there's that. So I got my imager. I'm kind of put these in the order that we're using, right? So SD card formatter, PL app, Raspberry Pi imager. So I've got the way to format my SD cards, and I've got the two different methods that we're going to use to install the operating systems. All right. This image right here, let's do, so I'm going to jump to documents real quick. And let's create a IoT security image files. Okay, so then in documents, good. So from downloads, I want to put let's put all of these this everything that I've got highlighted here: VirtualBox, Kali Linux, IoT security, Metasploitable, and PL app launcher. Those are all Cisco related IoT security files. So I'm going to put those there. I'm going to then unzip the image file. Just want to put it in this folder so that I'm not messing with it later. and then I'm going to delete the image. So then I have in here, I should have a fold. Oh, okay. I should not have deleted. And I'm glad I did this so I can explain what's going on here. Let me restore that real quick. All right, so I think this is a Windows issue, but on a Windows machine, right, when I unzip this folder, see this little dot right there that my pointer is pointing to? That makes this the extension. So this doesn't have any idea what's going on. So what you have to do on the zip file before you unzip it, you can either just get rid of that or put an underscore or a dash or whatever. Like I'm just going to do underscore. But I got to get rid of that little dot so that this actually unzips properly. Here is what it looks like currently. So if I unzipped it, it's got this like O_PLF. Like it thinks that's the actual extension to this file. So it has no idea what to do with this file once it's in that format. So we got to delete that folder. And then when I unzip this folder, when we extract this folder, we should get an image inside of this folder called Chestnut. Like it'll be an ISO file or an IMG file. So now we get, well, it comes up as a file now instead of a, right? So this one is actually what we want. So that's much better. We should be able to use that one. So that's the file that we need. So you have to, if we're on the Windows, and I don't know if this is I don't know if it has an issue with Mac or not. I don't know if anybody's here using a Mac at this point, but this little extra dot here, or the dot that was there, causes all kinds of problems. Okay. So you have to extract that file so that you can actually have. So then Renee, it should, I think it expands properly for you. It should extracts properly. I just know with mine, as soon as they started putting the little dots there, it started getting all kinds of weirdness. So let's recap what's going on. We have gone to, from our class here, from the Cisco IoT security, we went to 1.2.3.1 setup lab PL app on the Raspberry Pi. Okay. If you click on IoT security, this very first one, the image, it should take you to this page, which is the IoT security virtual machines page. And on this page, you should have downloaded Launcher, and you should have downloaded this image, and you should have downloaded this OVA for Kali and this OVA for Metasportable. Those are the files that we need. Okay. I have downloaded those files and I put them in their own folder. And then I extracted the zip file into a regular file. I'm not going to delete it this time because that's, I'll have to restore it again in a minute if I did something wrong. So I'm going to leave it there for now. So that's where I'm at this point for the Cisco material. I've downloaded everything that we need to download. I've put it all into one folder and I've extracted the image file from the download zip. Okay. Earlier we did the Raspberry Pi imager from the raspberrypi.com/software page. And earlier I downloaded the desktop OS so I could create a virtual machine out of a desktop OS. We also downloaded from the SD card formatter or the sdcard.org page, went to the downloads page and downloaded the SD card formatter for whichever machine we are working on. Okay, so that's kind of where we're at this point. If I look at my files, I go back to downloads. You can see there's the formatter. There's my Buster ISO. That's the desktop ISO that we ran earlier. Okay. All right. Now, the PL app, right, to create a file, to create this SD card, we're going to need a couple more items, right? So now you need a micro SD card reader. You need a reader, or if your laptop has a reader automatically, great. I have another one that's like a USB hub and a reader. Like, it doesn't have to be an exact reader like this, but the idea is something like that. I have like 5 or 6 different versions of that. So you've got Sabrent and Transcend. So Iot is another one. Right? So they just have slots for me to. So I'm gonna take an SD card. So I got a 16 gig. I think this is a class. So class 10, I think. And I'm going to insert that into the SD card reader, and then I'm going to insert that into my computer. All right. And this is what Windows does with anything that's got Linux on it. Like, hey, I need to format the drive. So the first thing we're going to do is I'm going to go ahead and format that drive, right? So I'm just going to use the SD card formatter that I installed a little while ago. Let me roll this up out of the way. So it's CNE boot. It has a 14.46 gigabyte drive. One thing I will caution you, and you should caution your students on, if they have external USB hard drives plugged in at this point, they should probably unplug them. And the reason I say that is because those are also recognized by this formatting tool and by other formatting tools as potentially the tool, you know, the card that you want to format, right? And if you format that, then you lose your data, which I've done. So luckily I use an online backup, so it wasn't a big deal. It did take forever to get all my data back, but I was able to recover it all. So just an idea, right? Learn from my mistakes, right? Unplug like any device that has storage on it that you don't want to screw up, just to make sure that you're only formatting the one card that we need to format, right? So in this case, my E drive is there. I'm just going to format it with a quick format, right? And it will expand the drive out to the full 14.46 gigs. And then it says, hey, you know, any warning from Microsoft on this drive, I just ignore. Okay, so that should be formatted. We'll close that. And if we go down here, we should see the boot drive and we can see that it's empty, right? So great. So I have an E drive that's 16 or 14.4 gigs, right? So properties 14.4, okay. And I'm comfortable knowing that E drive is my drive, all right? So to install the packet or the PL app, right? The Cisco PL app image, right? So we want to now install this image that we downloaded. I put it, right? I put it in my documents under Cisco. I thought it was Cisco. Oh, IoT security image files, right? So this is and I extracted it here. So that's the file that I'm going to put on my SD card. Right, so to do that, I'm just going to open up PL App Launcher. There's 2 tabs across the top. Okay. This first one, set up a new device. That's the page that we're going to use. Available devices is the page you'll use after we set this up. Okay. So E drive, remember E drive is the drive that I formatted. That's the drive I want. Okay. I'm going to browse to the image file. So the image file, let's go to the right one. So documents and IoT security images. And then I'm going to here. It didn't unzip properly. Kind of thought that was what's going on.
Yeah, I got warning though. I cannot uncompress it though.
So I took out the dot. I just took out the dot.
Oh, okay.
I'm gonna try that one, see what happens. So extract files. Extract to the same spot. what you should, yeah, see, I said that earlier, you should get a chestnut file. There should be a chestnut file. So this one is the one that I just did. There's no files. What's going on with my extraction today? Is anybody else having an issue getting your, like this should have just extracted.
Yeah, even I changed it, the dot to underscore, and
Mhm.
it still complain cannot uncompress it though.
Yeah, that's what's weird. And if I double click on this, well,
I think that after you uncompress,
uh-huh.
file doesn't have a format as IMG. Is
Yeah,
that-
that's weird. Like I just downloaded it from the page, right? That's,
yeah,
is anybody else having that same? I mean, we got one other person having that same problem, right?
yeah,
Tony, are you having that problem?
yeah. That's the same thing that happened when I uncompress.
Okay.
It doesn't show up as
Wonder
an
if-
file.
Yeah,
I wonder
Kelly,
if
all
this
you
is
have to
messed
do
up.
is change the file extension to IMG, then it should
IMG.
work.
Yeah.
So you think, okay. Yeah, see, that's a lot of, it's kind of weird. So here's, if I were to just, I'm just gonna extract the file like I normally would do, right?
Yeah, yeah.
So just,
Change the IMG, and then it should be able to.
that's weird though. It should normally, yeah, we're gonna try that, but normally this would show up as chestnut.img. So it seems like there's something. I wonder if there's an issue with this file that we're downloading. The other option, if we go to there's a different folder. There's a different folder called like large, like IoT large files or something like that. Let me try this and then I want to investigate that real quick. But so if we browse to here, to there, open, it didn't give me any issues there. So then I'm going to name this. So we're going to name this, let's see, 2020. That's W3. All right, and then for now, I'm just going to use the default Raspberry password. I am not going to connect it. I'm going to connect mine to a wired network. Okay. If you want to connect yours to your wireless network, you would put your SSID and your passphrase here. And then once you have those items set, right, what your SD card is, your image that you're using, the name of the device, the password for the device, SSID and password for your network, you would just click write disk image. And right, it's gonna it's gonna wipe out everything, and then you should get a countdown over here, another count up. So then once this is done, I fully suspect that you'll get an error at the end of this saying it could not write the config file. That's been the case for the last probably 2 years on this. So when you get there, just pause for a second and I'll show you what to do. So the next thing I'm curious about is if I were to go to, I'll go back into the class here. I'm gonna go back to our lab. I don't know why this lab is all of a sudden actually starting funny. set up the PL app. So instead of selecting IoT, I'm going to select like, I'm just going to select the launcher to take us to the same spot. It takes us to the same spot. There is, so now I'm going to cheat real quick and I'm going to go back to a different class. So the connecting things course, if I go to the same place or the same idea, like we go to the same, we're going to go to the same lab. To chapter 3, right? So here's the lab in chapter 3, and it's designed. It's a different image because if the image is for connecting things and not security. But this should take us to the large files page, which also has, yeah, it has the Raspberry Pi image and the Raspberry Pi 4 image. I don't know why the security course doesn't come here. I'm going to copy this into. So if you're running on a Raspberry Pi 4, you're going to want a different image. You're going to want this image right here. And then I'm wondering if you're on if this download here is different than the one that we just did. So I'm going to download this one. It's the same name, but I want to download it and see if it behaves differently than the original one. Is the Metasploitable, all these other things. So this is I put this link in the chat. This is to the IoT Fundamentals large files page. It has the files for all 3 courses. Okay. Here's the error that I expected to get: unable to write configuration, e:\chestnut.txt. You click OK, and you click update config only. You should get, oh, I didn't get it. It's not liking this at all. This is not working the way it's supposed to work. Interesting. Let me look at the drive. I think there's a problem with that image. That's not how it's to be. I said it was going to take us all afternoon, right? And everybody thought I was crazy. All we're doing is installing.
Okay, I noticed it's when you click on browse, it's also reading the zip file. Have you tried the zip file rather than the image file?
Does this,
Yep.
will it read the zip file?
Yeah, it
Okay.
does.
Because I got this now, right? When I tried to open up the drive, and the drive has nothing on it, like not accessible, can't read it. So you're saying if I go here, and instead of the unzipped file, I grab the zip file, and I do it that way. We're gonna click go, and then it's unzipping the file. So maybe this will work. I love it when things go this way. Close that real quick. And then I am downloading the image off of the large files page, right? So large files page. If you're using a Raspberry Pi 4, come to the large files page and get the Raspberry Pi 4 image specific for the Raspberry Pi 4. There are some fundamental differences in the firmware of that system that need to be addressed. Thus the reason for that second. Did we go past lunch? Oh my gosh, we're past lunch. It's 1 o'clock, right? We're supposed to stop at 1. Okay, let this stuff go. We'll come back at 2, okay? Or 2 my time, which is whatever time, like I've got people everywhere. We'll be back here in 45 minutes. I apologize. I completely missed it. I wanted to make sure. Don't turn off the camera. I'm turning off the camera. I'll be back. And we're going to let this run and see if it fixes. If it doesn't fix it, we'll just continue the process. Like the whole point was we were going to get these things installed this afternoon. So we started a little early, but then I ran into lunch. Do you guys want to just come back in an hour, or do you want to come back in 45? Choice is yours. I'm okay either way.
An hour.
An hour? Okay,
Yeah.
Let's do an hour. So come back in an hour. So 2:15 my time. So 1 hour from now, I'll put a timer up. It looked like it did not unzip properly. I think there's a problem with that download.
Kerry.
Yes.
Sorry, Kerry. I sent you a private
Okay.
private message, please. before?
Yeah.
I wanted to know what to do with that. Thanks.
I will track it down and answer the question.
Thanks.
All right. Okay. So yeah, go to lunch. I'll put a timer up.
Oh, I just asked you about the, Ralph kit for Raspberry Pi.
Okay.
So is that helpful? Does it work here?
Was that, you said the Raphael? Is that the one that said Raphael on it?
Yeah.
And I didn't, what is it? I don't know. I've never seen it. Raphael. Is it?
Can you go Google it and later?
Yeah. Raphael kit for Raspberry Pi. Oh, it's a Sunfounder thing. Okay.
Yeah, Sunfounder.
Yeah, that's. That kit has all kinds of good stuff. So this is the kit we're looking at.
I paid $64 for it. And
yeah, there's lots of cool things. I'm trying to see if there's a. I think the kids. First of all, the kit has a lot of cool stuff. I think that part, as far as like playing with Raspberry Pi and doing lots of cool stuff, that's going to work perfectly fine. This piece right there, and that ribbon cable, and what I'm looking for is if there is a USB to serial type of a wire, and I'm not seeing that. I'm not seeing so I think from a general, if you're doing the IoT connecting things course, this kit's going to do everything in that course plus more. And I think all we're really missing as far as the security is concerned is that one cable, that USB to serial cable. Doesn't look like there's something like that here. So yeah, other than that, this kit is a nice kit. And Sunfounder, I've had Sunfounder stuff for a long time. They have, they got some really cool demonstrations. Like this is a really cool. That is audio, and that looks like RFID, right? If I'm not mistaken. That's awesome. I like it.
all right, thank you.
Yeah, no worries.
Have a good lunch.
Yeah, take it easy. Okay, camera's off.
Oh, hi, just
I'm-
1 second.
Yeah.
Hey,
I'm still
I think
here.
the Pi 4 2.0, I can unzip it, no problem. I should see the chestnut, right?
Yeah,
After I unzipped it.
after you unzip it, it should be chestnut. Yeah,
Right.
that's always been my experience in the past. That's why I'm kind of, so like right here, this is the new one that I just downloaded.
Right. I think the original one maybe have some issues.
I think the one that they point to is the wrong one. Actually, I think
Yeah, it's corrupted. Yeah,
they updated it. So it's the large file version is the one that's going to be the right one. The one that's in the large files folder.
Okay. The second link that you posted,
Yes.
is
Yes,
for
sir.
Pi 4 explicitly.
There's one for Pi 4, and the one right above it is for Pi 3s and earlier. There's two.
Okay.
There's two images. Here's the page. Right. So this is
Right.
the large files page.
Yeah.
This one is the Pi 4. This one is Pi 3 and Pi 2s.
Yeah. I tried to download the Pi 4 2.0 and then it opened it without any problem. Unzip it.
Nice.
Okay.
Okay.
All right.
And then,
We see you back after the lunch.
yeah, sounds like a plan.
Thank you.
Bye.
Okay. See you. Bye-bye.